Good morning, guys. It's Naveen John on the call. Can you guys hear me? Could you please type in the chat window? Great. Thank you, Pravalika. And let's get started, guys. So here we go. Okay. So let's see. Come back here. I'm gonna bring up my screen. I'm gonna stop the share for one moment. And, one moment, guys. Sorry about that. Pardon me. I'm just extracting a few slides for a quick review, guys. So just bear with me. There you go. There you go. Sharing back again. Pardon me. We were not completed. Okay, Satish. I'll come to that one in a moment. And this is fun. Try to find you. I'm going to make you the co-host so that you can take up a few questions. Let's see, where are you? Here we go, Satish Pagadala. Okay. Making you the, no. Yeah, okay. We'll make you the co-host. Are you also, can you also share the screen, Satish? Share your screen. Let's see, you can unmute yourself, Satish. Okay, looks like, okay. You already shared it, okay. Should make it easy for me. Okay, so let's see. What is Hive, Satish? I'm not able to hear you, Satish, just in case you're answering. Can others hear Satish?
Hello.
Yeah, now I think something is, I'm able to hear you.
What's the question, Naveen?
What is Hive? What is Hive, Satish?
Hive is an open source resource, Naveen.
It's an open source?
Open source which is used to run projects, something like that.
Okay.
Which is used to handle large amount of data.
What is MapReduce?
MapReduce means the process of reducing the data into tabular forms so that we can visualize in a much similar, in a much shorter way.
What are the steps in MapReduce?
Steps.
What is SDR?
SDR.
What is the main advantage of cloud computing?
Multiple sources, I mean, so that we can, if one server is down, we can access from another server.
Okay. Do you remember what is the difference between public cloud and public and private cloud?
Private cloud are which are maintained by the companies. So for those who for the employees only, they will allow. For the external user, they won't allow. That is private server now. And the global server is Google, so that we can everyone can use global server.
Okay. Looks like you're sharing your screen. Can you bring up your lab account? Do you have it up anywhere? Click on.
I have to log in.
Yeah, log into that. Get into the Azure Labs. Do you remember what is the region, Satish?
It's like a subhost. That means a server. Regions means.
Okay. Try creating a virtual machine. What is the resource group, Satish?
Container that holds a relative source.
What do you think is resource?
Resource means collection of data which we read.
Okay. Is your internet slow or something?
Yes, Naveen.
What do you think is Azure Spot instance?
Didn't know, Naveen.
Pardon me? Not able to hear you. But okay, go ahead and complete creating a virtual machine quickly. Do you know why we give access to port 80?
Port 80. Don't know, Naveen.
Okay. Still creating.
Deployment, Naveen.
So, okay. Okay. While that is coming up, let me come back. Let me share my screen here for a moment. So share the screen. So yes, we'll share this one. Okay. This is the storage. May I stop the share. Back here. Back here. save this. Okay, I'm going to share it again. It's going to be this one. Okay, let's see what we have here, guys. Are you seeing the complete slide, guys? Satish, are you seeing the complete slide?
Yes, Naveen.
Yeah, not the individual slide, right? The complete slide.
No, Naveen. Complete slide.
Yeah, okay, thank you. So each availability zone has independent and redundant power, networking and connectivity. Availability zones in a region are connected through low latency networks. What do you think is an availability zone, Satish?
Availability zones, that means the data which is already in the server, which is that means a copy of the original data is present here, I think so.
Copy of the original data. Okay, let's see, come back here. Back here. And back here. So let me draw something. And there it is. Back to here. So imagine this is India, this is Asia, somewhere here is USA, somewhere here is Africa. Africa is here, that is South America. This is North America. This is Asia, China, Russia. Okay, here's China. This is Africa. Here's Europe. So generally, region is something, a group of availability zones. So here is Hyderabad, here is Mumbai, and let's say here is Calcutta. So availability zones are generally at the same location, Hyderabad, and let's say here's a Secunderabad. They're generally close to each other. So more precisely, a region has a group of availability zones. So Mumbai and Pune, Calcutta, and maybe something close to it is generally what is an availability zone. So in other words, a region is nothing but a group of availability zones. Are you understanding, Satish?
Yes, Naveen.
What does independent and redundant power mean?
Each of them are not dependent on the power and networking. If I at one side the power got lost, or it is facing issues with the network, we can access from another location as Hyderabad or Chennai.
And as availability zones in a region are connected through low latency links. What is the meaning of low latency? Others can give a less delay. Yeah, you can help now. Satish, as I'm asking the questions, guys. Okay. So that is low latency means they are high performance. The delay is less. The delay is less means we get higher performance is what it is. Okay. Advantages of the regions include high availability, low latency, global footprint, and adhere to government regulations. What does high availability mean, Satish?
It is available throughout the day. That means 24/7, highly available. If one server got collapsed, we can access from another server as the data, backup data has been is there in that another region.
Good answer. So in other words, multiple regions, if one zone is down, we can get the data from other zone. If the complete region is down, we can also get the data from other region. That's what that is. Low latency means?
Less delay in...
Good. What is global footprint?
Can access globally, I think so.
So what is the advantage if you're able to access it globally?
We can access the information anywhere.
Which means if your application has been deployed in London, generally the people in London and the surrounding areas are able to access the application fast and quick. but people in the other parts of the world may not be able to access it. So that is where, if we make the application available in multiple regions around the world, then the other customers or the people who are accessing your application will be able to access it in a faster way. Understanding, Satish?
Yes, Naveen.
And the advantage of region is government regulations. Adhere to government regulation means, and what does that mean?
Follows the government regulations, I think so.
So in other words, England may have its own government rules and regulations and for the London-based citizens, and US may have its own rules and regulations. And similarly, other continents and other countries may have. And so in other words, every region can be configured with their own rules and regulations. That is also an advantage of region. Okay, okay, Satish?
Yes, Naveen.
The best approach to survive a data center failure is to deploy your virtual machines to multiple availability zones. What does that mean?
If the data center is failure, multiple Azure, it is same as the previous, Naveen. If we deploy in multiple servers, we can access from multiple sources, right?
Good answer. So in other words, the region is a group of zones. A zone can be a group of data centers. So if your data is unavailable in one data center, we are able to get it from another data center in a zone. That's what that means, okay? Even if you stop a virtual machine, hard disks and data are still stored. You need to pay for storage. What does that mean? Is your virtual machine done?
Didn't get in. Even if you stop a VM, hard disk and data are still stored. You need to pay.
Is the deployment of your virtual machine done? Satish.
Yes, Naveen.
Is the deployment of your virtual machine done? Can you hear me, Satish?
Yeah, I can hear you now. I'm still thinking.
No, I'm asking, you were creating a virtual machine earlier, right? Is that
yeah, Naveen. Okay. You're asking about that. I am thinking, I'm downloading that is.
No. What about the deployment, buddy?
Deployment done, Naveen. I have
That's what I'm asking.
downloaded the RDP file.
Share your screen now.
Wait, Naveen.
And let's see, don't deploy it. What I want you to do is, no, you don't have to deploy it. Cancel that.
Okay.
Go back to that virtual machine. Okay. Now there should be something called, let's say, before we do this one, in your search box on the top, not the left-hand side, on the top, search for resources. Type in resources.
Resource groups, Naveen.
Okay, select a resource group. You have two resources. Click on new. Essentials is deployed and resources. And if you scroll down, okay, you have, what is NSG? VM Satish, NSG means? What does NSG stand for?
NSG.
Give him help. The hint is on the screen. If you just look towards the right-hand side, it says Network Security Group.
Okay.
Right?
Yes, no.
Okay. So then you have public IP address, then you have virtual machine. This is a new VNet is nothing but a virtual network. These are all the resources in this group. Okay. Now go back to your virtual machine. Go back to your virtual machine. Satish? Is this the one that you just created?
I think so. Naveen. Wait, I will check my download so that I. Yeah, Naveen, this one.
Okay. And click on disks on the left-hand side. Okay, so there is your disk. Disk is nothing but hard drive. Okay.
Hard drive, yes.
Now go click on overview.
Where, Naveen?
On the left-hand side. On the left-hand side, it is the first one. Okay, now click on delete. Okay, apply force delete. Check the checkbox. Click all the checkboxes. So these are the resources. The OS disk is hard disk, network interface card, public IP address. These are the resources which have been created when you create the virtual machine. Okay, by default,
Okay.
by default, the disks are not, the storage is not deleted. Click on delete. Okay, so it's deleting.
Yes, Naveen.
While you are at it, click on the Cloud Shell. Cloud Shell. On the search box, on the right-hand side of the search box, it is the first icon. On the right-hand side of the search box, it is the first icon. On the left-hand side of the notifications.
Cloud Shell.
Left-hand side of the notification. You just clicked on the notification, right?
Yes, Naveen.
Side. Left-hand side. Left hand. One more left. That is the Cloud Shell. Click on that.
Okay.
Is it coming up? Okay.
Yes, Naveen.
Click on Bash. Create storage. Running into the same problem as yesterday. Okay, I just want to check that. Okay. That's okay. I think the deletion is still in progress. So let me come back here, share my screen again.
Successfully deleted now.
Okay. So even if you stop a virtual machine, hard disk and data are still stored. And we need to pay for the storage. You understand that, Satish? When you delete a virtual machine, we also need to delete the hard disks. Otherwise, we'll need to pay for that. Yes or no, Satish?
Yes, Naveen.
Be quick, buddy. Don't take so much time.
I thought my mute is mic is on mute. I'm speaking, but my mic is in mute.
Okay. Activity logs kept for 90 days help you to find who performed what actions on your Azure resources. So what do you think is the meaning of that, Satish?
Usage of the Azure cloud resource by how many members for a period of 90 days now.
So in other words, if somebody created a virtual machine, if they added a hard drive, if they added any other components to your virtual machine, if they made any modification, the activity logs will tell us, okay?
Okay.
Okay. Every Azure region has at least 3 availability zones. Do you think that is true or false?
I think true now.
Every Azure, I think it is false because I think from yesterday, if you recall, the Western US does not have 3 availability zones. All availability zones in an Azure region are present in the same data center. What do you think? True or false?
Same data center. False, Navin.
Why?
Multiple locations, they can be in multiple locations. I don't in Azure region are present in same data center. They can be in multiple data centers also. No, Navin.
Good. Which of these are the advantages of the regions?
All the above. Navin.
Good. Availability zones in a region are connected through low latency links.
True, Navin.
Which of these help you to attach virtual disks to virtual machines or block storage?
Block storage. Azure disk, Navin.
So in other words, virtual disks are nothing but the Azure disk, that is the hard drive, so simple as that. 2 or more instances in 2 or more availability zones in the same Azure region give you 99.99% availability. In other words, this is called 4 nines. And explain me the meaning of this one.
Or availability, so if the availability zones are high, and that means the accuracy is high. No, Navin.
Good. So in other words, if we maintain our virtual machine in multiple availability zones, then in multiple availability zones, then we get high availability. 99.99% is 4 nines. 4 nines means roughly, I think around 4 hours is the downtime we may expect in a month. The rest of the time, 99.99%, our application is guaranteed to be up and running. Understand that, Satish?
Yes, no.
Using virtual machines to deploy applications or databases is considered as infrastructure as service. What is the meaning of that?
So by using virtual machines, we can deploy applications, infrastructures. Yes. The virtual Azure provides services, no, Navin, to create application, to deploy applications on Azure.
Okay. So in other words, virtual machine is an infrastructure. If you're deploying a virtual machine, then that is nothing but infrastructure as a service. Okay. Configuring SaaS solution is only responsibility that you're responsible for when using software as service, when using SaaS. All other responsibilities are taken care of by the service or the cloud provider. What does that mean, Satish?
Configuration of SaaS solution is only responsible that you are responsible for when you are using. As they provide some services, it is their responsibility for
What do you think other responsibilities are that the cloud provides?
taken care by the service.
The other responsibilities are availability, scalability, global footprint, and things like that. Okay. Logic Apps is a serverless orchestration service recommended for automating workflows. Okay. Do you remember what is serverless mean?
Serverless. Which do not have server name. Well, impossible, I think so.
Okay. Serverless is also having a server, but it is only having for a limited amount of time. So imagine a coffee shop where let's take Divya. Divya is an owner of Starbucks coffee shop. What is the problem with Starbucks? Well, during the nights there is nobody coming. It's only in the morning hours and things like that. The Starbucks is there. But what did she do? She rented the store. What is the store? The store is a virtual machine. The application is making coffee. But let's say Dhanushvi, by the side of Starbucks, she opened another coffee shop. What did she do? She observed most of the time people come to Starbucks coffee, let's say during evening hours, let's say 5 to 6, 5 to 7, or 5 to 8. So now what Dhanushvi is doing is, that is when the high traffic is. She's not renting a store completely. She's only renting a store only during that time of the day. Maybe 5 to 7, 5 to 8, she rents it and then she closes it off. Why? She knows there is high traffic there. And what is happening as a result of that, she doesn't have to pay for the rest of the hours of the day. She doesn't have to pay the rent and things like that. So what is the store? The store is the server. That is server full. That is Divya's way of operating the business. Whereas Dhanushvi, she is just paying only for a limited time. In a day, she is further limiting. That could be 5 minutes, that could be 5 hours. Okay, serverless use servers, but as long as the code is run, they will use it. Maybe the code is running for only 5 minutes or maybe 50 minutes. After that, the server is automatically getting closed. In other words, after that, there is no server, there is no store, there is no shop. That is what is serverless. Okay, Satish?
Okay, Naveen.
So Logic Apps is a serverless orchestration service recommended for automating workflows. Do you know what is the meaning of a workflow?
Flow of code, Naveen.
It is
Flow
flow
of coded work, yes.
And what is work? Work is a group of steps. So
Group of stores.
So it's a flow of steps. That is a workflow. We are automating it. Logic Apps is a service which is serverless. It will allow us to automate a group of steps. Is one way to think of that. Slightly deep, but we'll try to revisit that. When using PaaS, cloud provider is responsible for OS, application runtime, scaling, availability, load balancing, etc. You're responsible for configuration and application code if needed. What does that mean? What is PaaS?
Platform as service, Naveen.
Okay, so what do you think this is telling?
They provide some cloud provider is responsible for some of them like application running, auto scaling, availability, and load balancing. We are the user is responsible for configuration and application as service. As we are using the application, we are responsible for that.
Okay, so in other words, in platforms as service, what is it back to a Starbucks coffee shop? What are we doing? Application runtime means that is the store where we are running our coffee shop. Auto scaling means every time, every 1 hour, if more than 70 customers are entering into our coffee shop or coming to our coffee shop, then what we are doing is we are immediately opening another store. We're opening multiple stores, and if that threshold is down, it's coming to 30, then we are automatically scaling down. So we're increasing the number of coffee shops if more customers are coming, and we're automatically decreasing. And what is the building owner? Building owner is a cloud provider. The cloud provider is giving us the feature or the facility where he says, if you want to, you can open multiple stores and you can reduce them. I will only charge for what you need. That is scaling. Okay. Availability is at any point of time. If there is any problem in any one store, what is store? Store is server. That means if there is a problem in a server, then automatically he's taking care of it. The building owner is going to be taking care of it and make the store available. Balancing is again, he's telling, if you have too many customers coming in, then what we will do is we will open, after you open multiple stores, we will redirect each customer to one store. That is load balancing. It's load balancing the requests. So in platform as service, what is happening? Only we are taking care of the code and the configuration. For example, when we use SQL, we are using SQL, for example, PostgreSQL, when we use, we are writing customized query. We are not deploying a virtual machine. We are not creating a virtual machine. All those things are already created by the cloud provider. And you just work with the platform. Platform is nothing but the PostgreSQL, where we write the code. Okay, Satish?
Yes, Naveen.
In-memory databases like Redis deliver microsecond latency by storing persistent data in memory. This is slightly advanced topic. We have not talked about it, but we will talk about it, but I will try to explain this one. In-memory database is another type of database. Redis is a database where generally the data is stored in a database, whereas here the database itself is in the RAM of the memory. That is what is called in-memory database. And Azure Cache for Redis is a managed service for Redis. Managed service means, remember, they're all managed and taken care of by the Azure cloud provider. We don't have to manage them. If we have to manage them, that is called self-managed, is what it is. So Redis is an in-memory database is what it is. Okay, Satish?
Yes, Naveen.
Okay. You need to first remove the log before you can perform actions on the resources. Sometimes on the databases and other resources, they get logged. So what can we do is we can remove the logs. That is also slightly advanced one. We'll revisit that one. But let's see which of these options do not help you reduce the cost for your Azure virtual machine. What do you think, Satish?
It do not help to reduce costs. Use for instance.
Okay, that's a tough question. Do you remember what is Azure Spot Instance? Spot Instance is like a commodity server. They're cheap servers. They're cost reducers. Reserved VM instances, some of the virtual machines are reserved. We did not discuss much about them. Using them also, the cost reduces. The only thing which does not reduce the cost is dedicated hosts or dedicated servers. Dedicated host or dedicated server, pardon me, is something like we're telling the building owner, I want the complete floor only for myself. So what is that? As a result of that, since we are taking the complete floor only for ourselves, our cost will increase. Okay, buddy?
Okay.
So which of these represent the ability of a system to provide acceptable behavior even when one or more parts of the system fail? Tough question. Answer.
No more parts of the system. Scalability, Naveen. Scalability dividing. Availability.
Okay. So it is resilience. In other words, ability of the system to provide acceptable behavior even when one or more parts of the system fail. Here we're talking about part of a system. A computer has a server, has RAM, a server has hard drives, it may have multiple hard drives. If the RAM goes down, then we cannot do anything. Can we have multiple RAMs? Maybe we can. If the server has multiple hard drives and one of the hard drives goes down, then we can still work with other hard drives. That is called resiliency. Availability is your server is down, your data center is down, your zone is down, then that is availability. It is a complete thing which is down. Scalability is increasing. Resiliency means, imagine in your coffee shop, you have a person who's taking the orders. Another person is making the coffee. Behind the scenes, another person is cleaning the bathrooms. If the guy who's cleaning the bathrooms has not come, that is part of your coffee shop, is not in service or not working, then you don't need to close your coffee shop. Somebody needs to take care of that. What is that? That is the resiliency of a coffee shop. Availability is your complete coffee shop is down. If it is down in building 1, building 2 is coming up. They will say, hey, you're redirecting all the traffic to building 2 and saying there's another Starbucks in building 2. Scalability is when there are a lot of people coming to the coffee shop. We're telling, hey, we have multiple coffee stores. Since there are too much people waiting in the queue, you can go to the other coffee shop. Okay, Satish?
Yes, ma'am.
Okay, let's see. Read the question and answer it.
Cost of two VMs with same machine type is two different regions are equal. False, ma'am.
Why?
Same way virtual machine with different regions. Cost of the server is based on the region.
Very good. If you remember that one. So for every region, the price is different. That's why if you have multiple 2 or more virtual machines in different regions, even though they are the same configuration, their cost or price might be different. Okay. What do you think is the difference between, okay, read the question and answer.
Deploying application or database to bigger instances. Scaling or horizontal scaling. Horizontal scaling, ma'am.
Okay, it is vertical scaling. Vertical scaling means you have, let's say, a server with 8 GB RAM. Now you're suddenly increasing the RAM to 16 GB or maybe 32 GB. That is called vertical scaling. What do you think is horizontal scaling, Satish? So vertical scaling is something like your coffee shop, let's say, is in 1000 square feet. And your customers are increasing. So now you want to increase it to 2000 square feet. You're increasing the size of the coffee shop. That is vertical scaling. Horizontal scaling is about scalability.
Adding of more virtual machines.
More virtual machines, more coffee shops. Okay.
Yes, ma'am.
Read it, please.
You will not be billed for a VM or storage after it is stopped. False, ma'am.
Why?
As we previously discussed, we have to delete the storage, disk storage.
So we just discussed, even though we delete the virtual machine, the storage will be still charged. Okay, read it, please.
You went to your virtual machines to survive a data center failure. You are using a virtual machine availability set to deploy your VM. Does this always meet your some part of the question got not visible. REMP
Does this always meet your requirement? So your virtual machine failed in a data center, and we are using an availability set, a VM availability set, to deploy our virtual machines. Does this always meet your requirement is what they're asking.
Not always meet.
I think the answer is false. That's a slightly tough question. So it's like saying in your building, if your coffee shop is down, we are saying, hey, in another building, there's a coffee shop. It is not a guarantee or it is not a necessity. Just because we have configured availability set, in availability set, there is one of the options which does not really guarantee. So I think the answer is that is not always true. Azure Policy helps you create, assign, and manage policies. You can automatically ensure that resources stay compliant with defined standards and SLAs. This is also, we haven't talked about much about SLAs and things like that. But Azure Policy, what is a policy? It helps you create, assign, and manage policies. Policies are nothing but group of rules. Who can access what, who cannot access what, and what are the other things based on which somebody can access the resource, somebody can delete a resource and things like that. That's where the policy policies come in, we will talk more about that. Okay, read the please.
Azure Information Protection helps us classify and protect your documents and emails. You can add labels in indicating that kind of protection or encryption you want. It uses Azure rights management. Azure RMS integrates with Office 365, Azure Active Directory, etc.
Okay, so Azure Information Protection helps you classify and protect your documents and emails means AIP, Azure Information Protection, is about taking our data, which is our documents and emails, and we are encrypting it. That is provided by Azure Information Protection. Internally, it is using the rights management also to integrate with Office 365 and Azure Active Directory. But for us, we need to remember Azure Information Protection, AIP, is encrypting our data and keeping it there. Okay, Satish.
Yes.
Azure Government is a cloud environment specifically built to meet compliance and security requirements for US government. Okay, so it uses physically isolated data centers and networks located in US. Only US government entities and contractors are eligible to use Azure Government services. So in other words, Azure Government service is only specific for US government is what is the gist of it. Okay, Satish.
Okay.
So that is a environment, that's a separate environment, which is making sure all the servers are within USA because all the data is confidential with respect to US and things like that. They are creating a separate environment there. And let's see, public cloud. You host everything in the cloud. You do not need a data center anymore. What does that mean, Satish?
Everything into cloud. You do not need cloud is a storage center like that now. If we include our files in that, we can access anywhere.
You can access it anywhere. So in other words, you don't need to buy anything. You can rent everything in the cloud. That is what is public cloud. Okay. We don't need to build a data center. We don't need to build a building or a room or a store. That is automatically given by the mall owner or the building owner. Access tiers. Hot store is something which we frequently access the data. Cool, we infrequently access the data. And archive is rarely accessed data. Hot, cool, and archive are the three mantras. Catching it, Satish?
Yes, ma'am.
Okay. Azure files, managed file shares. Okay, managed file shares are file sharing is nothing but like creating a network drive, connect from multiple devices. We can connect to Azure file shares, which are Azure network drives. They act like our network drives in our computer, and we can access all the files and things like that for sharing with them. Okay, Satish.
Yes, ma'am.
Network security groups allow you to configure multiple inbound and outbound security rules. You can allow or block traffic based on source or destination IP address, protocols, and port. You can restrict the traffic between resources such as virtual machines and subnets. We can restrict the traffic between resources such as virtual machines. We can allow or block traffic based on source or destination IP address. And it is allowing you to create multiple inbound and outbound security rules. So that is what is network security groups. It is nothing but it is a group of rules is what it is about. Catching it, Satish?
Yes, ma'am.
Okay. So let's do this. It's 12:03. Let's take a short 7-minute break and regroup, yes? Okay, Satish?
Yes, ma'am.
Okay, Satish, are you back?
Yes, Naveen.
Right. Okay. So network security groups allow you to configure multiple inbound and outbound security rules. You can allow or block traffic based on source or destination IP, protocol, and port. You can restrict the traffic between resources such as virtual machines and subnets. Okay, so in other words, short and sweet network security group is something which can, for the sake of simplicity, we'll call that it is a group of rules. It is allowing us to configure a group of rules which is inbound and outbound rules. Okay. Oops. You want your virtual machines to survive a data center failure. You're using a virtual machine skill set to deploy your virtual machines across multiple zones. Does this always fulfill your requirement? What do you think, Satish?
Previously discussed on false.
It's a false, huh? So here
Yes,
I'm saying a data center is failing to deploy across multiple Azure availability zones. So I think the answer is true here because they're in multiple availability zones, and a zone is a group of data centers. So if one data center fails, the other data center, we should still be able to access the data. Okay. Okay, read it.
An Azure VM has been manually shut down. You want to find out who initiated the shutdown. Which of these servers would you recommend?
Which of these
Servers would you recommend?
services?
Okay, services.
So what do you think?
Monitor.
Okay, I think the right answer is activity log. It is the log way which will tell us who did what with our virtual machines and things like that. Okay.
Okay.
Monitor is different, advisor is different. We'll talk about them. So which of these operating systems are supported by Azure virtual machines?
Good.
Good. And read the question.
Which of these configurations provide 99.99 availability of your VM-based deployment? Multiple VMs in 2 or more availability zones.
Why?
Or regions. More number of VMs, more number of availability zones means more number of most accuracy is high.
More availability, not accuracy.
More availability. Okay.
Okay, Office 365 is an example of what kind of service?
Platform as service.
I think it is software as service, not platform as service. Okay, we're just using the software. You're not developing anything on Office. Okay.
Okay.
SQL database is?
Database. We are developing, we are writing some code. No, I mean,
Good.
Platform as service.
Good. And what about the virtual machine?
It is also a platform as service. Now. We are using virtual machine.
Okay, virtual machine is a machine. A machine is an infrastructure.
Okay.
As a service. Okay. Okay. Resources in the same VNet can communicate using private IP addresses even if they are in different subnets. What do you think is the meaning of VNet? It is virtual network. So what is the meaning of this statement?
Resource in the same virtual network can communicate using. They can be communicating using a private IP address.
What is the other kind of IP address other than private?
Public IP address.
So what is the difference between private and public?
Private means which can be used by some of the people, those who are obeying the policies.
Private means within your network. Public means
Network.
you want to communicate to the internet.
Okay.
Okay. DDoS, denial of service, distributed denial of service, large scale attacks to bring your apps down. In other words, DOS is denial of service. That is nothing but somebody is trying to
Overload the server.
overload or hack your server and things like that. That is large scale attacks is what it is. Okay. So
Okay.
public cloud advantages. Stop guessing capacity, elasticity. Pay only for resources you use. Stop spending money running and maintaining data centers. Go global in minutes, which is easy geo distribution. Explain me each of these things. What is elasticity?
Large amount of storage.
And
Elasticity. If it's increasing in the capacity.
good. So in other words, if the traffic is increasing, we want to scale out. We want more virtual machines. And if the traffic is decreasing, we want to reduce that. And that is happening automatically. That is what is elasticity. Cloud is providing us. Okay. Pay only for resources. So pay as you go means?
Only pay for those services which we use.
Good answer. And go global means?
What I mean?
What is the third one?
Go global in minutes. Can be accessed globally.
Can be accessed globally. And in minutes we can.
Minutes. In minutes, yes.
Hey, when I'm talking, just hold on, okay? In minutes, we can set up a virtual machine, we can set up a software, and we can be up and running. We don't have to set up an entire data center, the servers and all those costs are reduced and the time is also reduced, okay?
Yes, sir.
Permissions or roles assigned to the user at the resource group level are inherited by all the resources in the group. We are yet to see this one, we are yet to discuss this one. So in other words, the permissions that we create at a high level resource group are automatically inherited to the other resources. Okay. So management groups allow you to manage access policies and compliance and multiple subscriptions. So all subscriptions and resources under a management group inherit all constraints applied to it. So we're also yet to discuss a little bit about the subscriptions, resources, and management group. So I won't talk much about it now. Let's move to the next one and see. By default, a resource group can have resources from multiple regions. That's a tough one. Can you explain that? We talked about this one earlier. Can you try to recall and tell me what that is?
Group can have resources from multiple regions. As we are accessing the data from multiple servers, resource groups may be same. I mean, if we are accessing data from US, and we have a server located in Hyderabad, like that, right?
So in other words, each resource group is nothing but a group of resources, and we can create resources in multiple regions, but in one resource group, you can use the resources in other group. That's what it means, okay? Okay, so let's say you have, for the sake of simplicity, 2 coffee shops. There is a coffee machine in one coffee shop, but in another, in the neighboring coffee shop, which is ours, we don't have a coffee machine. People are manually making it. But if needed, we can borrow the coffee machine in both the shops. Catching it, Satish?
Yes, ma'am.
You need a subscription to create resources in Azure. An Azure account can have multiple subscriptions and multiple administrators. Each subscription can have multiple administrators. What does subscription mean?
Subscription means taking the permission to use their resources. Paying for access.
Subscription, we have free subscription, we have pay as you go subscription and premium subscription and
Premium
things like that.
subscription.
That is what is a subscription. So based on the subscription, administrators can be created. But what we are saying is a subscription can have multiple administrators, is what we are saying. So we may have taken a particular pay as you go. And we can have Niharika and Lavanya as administrators for that subscription, is what it means. Okay.
Okay.
Okay. We can convert a free trial to a pay as you go subscription. All resources will be available as is in the new subscription. What does it mean?
Can convert a free trial to pay as you go. If you are using a free trial by paying the amount, we can use that extra features. We can access extra features by paying.
Why does somebody convert from free trial to pay as you go?
Free trial to pay as you go. Free trial is only accessible for some time, I think.
So in other words, you try something in free trial. If it works, then you subscribe to pay as you go. Okay.
Yes, ma'am.
So Azure Sentinel, again, we did not discuss much, is security information and event management. SIEM solution in Azure. It helps you detect threats and respond fast using AI. In other words, it is nothing but a service which is constantly analyzing the threats to our services to our servers and things like that. It is using machine learning and deep learning techniques and giving us suggestions or recommendations if there is a threat on our servers and things like that. So SIEM is security information and event management. For now, that is what that refers to. Okay, just-in-time VM access feature in Azure Security Center helps you log down inbound traffic to Azure VMs. Open up only when you need access to the VM just-in-time traffic. So just-in-time traffic, we're yet to discuss that. But at that point of time, you want some traffic to be allowed. And what can we do? That is where Azure Security Center gives us that kind of a access, is what it means. Again, we haven't covered that, so that also I'll proceed. But read the question and answer it.
Provisional virtual sector and with Windows Service 2016 is classified as virtual server and Windows server.
Provisioning virtual server means you are creating a virtual server. Is that SaaS, PaaS, or IaaS?
Yes, no.
Good. What about installing an SQL Server database manually in Windows virtual machine? Is that SaaS, PaaS, IaaS, or hybrid solution?
Installing SQL Service manually. Software as service, Navin.
I think that is IaaS. In PaaS, they give you the SQL Server. In IaaS, you take the server and you install whatever you want, whether that is a database or whatever it is, okay? That is infrastructure as service, okay? Next. Read it, answer it.
Platform as service solutions like Azure Web Applications or Azure SQL database provide full control of underlying operation system. I think true, Navin.
No, let's see. It's a database. They give us the database, but they are not giving the full control. We are just using the database for writing the queries. We're not modifying the SQL database and things like that. So that's why it's a false. Okay.
Okay.
Read it, please.
Platform as service solutions like Azure Web Application provide you with configuration operations to scale manually or automatically your application. Web application provide you configuration. I think true now.
Why true?
Scale set we can scale.
Okay, so in other words, in platform as service, we can configure and write the code. So here we are saying, can we configure? Yes, that's we can configure it. That's why it's a true. Okay, read it and answer it. Quickly, buddy. Satish.
False level.
Okay, that's a false because the software, for example, Gmail, we don't install it. We directly use it. It's automatically, you're just accessing the website and things like that. Office 365 is also installed for us. So read it, please.
If you are using a software as service like Office 365, which of these is your responsibility? Defining, scaling, maintaining, configuring SaaS solution.
Good. Okay. Azure keyword securely stores and access secrets, examples, keys, passwords, certificates, or cryptographic keys. So in other words, Azure keyword is a service. This also we'll discuss maybe tomorrow or something like that, or in more detail. This is where we can store the passwords and confidential information that we don't want to programmatically use. So it is all encrypted and things like that. That is referred as a key vault. Vault is something like, a secret almara is what it is. So that's Azure keys is nothing but the confidential certificates and things like that. Azure AD Connect, it synchronizes on-premise Active Directory with Azure Active Directory, synchronize all the user details, including password. So Active Directory is nothing but we have the usernames, password, what they have access to, the permissions, roles, and things like that. So on-premise is your own company and cloud is cloud. So we can synchronize all of you users in the Active Directory, which is a Windows-based list of users with the cloud-based list of users. That is what is Azure AD Connect. It connects the on-premise with the cloud Active Directory. Okay, Satish?
Yes, sir.
Just one line definition there. And modern life cycle policy covers products and services that are serviced and supported continuously. Microsoft will provide a minimum of 12 months notification prior to ending the support if no successor product or service is offered, excluding free services or preview releases. For security updates, 30 days notification action on customer's part is required to prevent significant degradation, which means they're giving us 1 year or 12 months notification if they are stopping any service or product, and is what is slightly important. Security updates, any service or product that we are using, if they have any updates, they give us a 30-day advance notification, as simple as that is. That is something to be kept in mind. So resource locks prevent accidental deletion or modification of resources. We can have multiple locks on the resources. We're yet to see, we're yet to discuss, so I won't discuss much. Then again, service help, just a quick definition here. Personalized alerts and guidance for Azure service issues, personalized based on your Azure storage, subscription services, and regions. So in other words, they're nothing but personalized alerts. Azure Service Health. For each service, how it is performing. At a subscription level, service level, and region level is what is Azure Service Health. It is the health of any service is what we can say. Again, a quick introduction, guys. Okay. Another quick introduction, Azure Monitor. It gathers, analyzes, and visualizes logs and metrics. It creates smart alerts. That means we can send SMS, emails, and other kind of notifications or alerts and attempt to automatically take corrective action. Automatically send an alert if an Azure VM is stopped. So that's an example. If somebody stopped a VM, started a VM, we can send an SMS, email, or maybe a WhatsApp message, other kinds of things. That is what Azure Monitor is doing. It is monitoring, is what it is. Then Azure Advisor, automated recommendations to improve reliability, security, and performance, achieve operational excellence, and reduce costs. In other words, it recommends, it gives us recommendations from a reliability, security, and performance standpoint is what it is. This is advising. This is giving us some recommendations from cost per performance and things like that. And Azure Monitor, you can think of Azure Monitor like a police in your mall or in your building. This guy is monitoring. Hey, somebody has stepped into, stopped your store. So we can configure, we can send an email if something looks suspicious and things like that. That is like a police. Azure Advisor is like he comes to your store and he visits and says, you can make this change to run your business well. It is also giving us recommendations in security. So internal security, it does is Azure Advisor. So in other words, let me see. Again, it is also covering a little bit of security, but more importantly, the cost and operational excellence, how you can better run your services is what it is also giving us. Okay. Application insights. Insights means knowledge. VM insights, container insights, log and log analytics features are features of Azure Monitor. Okay. So again, Azure Monitor, it is like a police officer is telling you from a application point of view, from a virtual machine point of view, from a container point of view, what are some additional things that we can do, optimize and things like that. We'll discuss these things in the coming up days, guys, but I'm just giving a one-line introduction. Azure Blueprint is slightly deep on one or more policy, role, errand template, resource group configurations. Your architecture team can create blueprints adhering to organization standards, patterns, and requirements, which means generally an architect will go ahead and create a blueprint for each of the application. There is a separate architecture for different kinds of applications. So rather than creating everything from scratch, what they can do is they can create a blueprint and they can bring up the skeleton of the applications using these blueprints. Your teams can use the blueprint to create resources, helps team to quickly set up environments adhering to organizational standards. Means this is, the blueprint is like, you can think of this is like an architect of our coffee store. What does this guy do? Whenever we want to open a coffee store, we go to this guy and we get an architecture saying that, hey, my budget is, let's say 10 lakhs or 20 lakhs. So in 10 lakhs or 20 lakhs, he'll give you what are the types of coffee machines, what are the types of chairs, what are the types of desks. He has a blueprint of everything. And what is that? That is blueprint. It's giving an architectural blueprint for each of the coffee store, or an architecture of the coffee store is what you can think of it, guys. Next, public preview. We may have briefly discussed this. Available to all the customers, but with no SLS, service level agreement. We haven't discussed about that. We can experiment with the services and provide feedback to Microsoft, not recommended for business critical workloads. In other words, public preview is a preview. Before you go to a movie, they show you the previews. So before you are checking out some new features and things like that, they're giving you a preview of the features. So if it is very important and for your business, you don't preview it, you actually put it in production. That is what public previews. A few new features, they're giving a preview of that for a quick testing, for a quick for feeling how it is and things like that. If you like it, you can actually subscribe and use it in your production and things like that. So continue, Satish. This is a tough question.
Which of these visualizers operating system?
Virtualizer.
Virtualizer. operating system. Virtual machine.
It is container. Virtual machine is like a machine inside a machine, which is also virtual, but more precisely, it is a container which is virtualizing the operating system. So in virtual machine, it is like your physical machine is your first floor. In your first floor, you can have 3, 4, or maybe 10 stores. Each store is a virtual machine, whereas container is, imagine, container, you can have multiple containers in a single floor. It's like a container is acting like a store. But imagine container 1 is a Starbucks coffee shop, container 2 is a McDonald's, container 3 is an Indian restaurant. What are they doing? For all these things, imagine there is one kitchen. The kitchen is common for everything. In a virtual machine, the kitchens are separate. Whereas here, the kitchen is common. What is the kitchen? The kitchen is the host operating system. So it is referred as a container, is what it is, okay? But let's go ahead. Continue, Sadish.
You want to run one container quickly. Which of these services would you recommend? Azure Container Instance. First one.
Do you know why? Okay. Azure Kubernetes and Azure Service Fabric are orchestration containers, container or orchestration of containers, which means if we want to create a group of containers, we use Kubernetes and Service Fabric. Here we are saying we want to create one. So we create Azure container instances. Okay, next one.
You want to implement a microservice architecture using a cross-platform container?
Tough question.
Solution. Which of these services would you recommend? Your Kubernetes service.
Yeah, it is Kubernetes service. Container instances, you want to create one container instance. Kubernetes is platform independent. It's a cross-platform. Cross-platform means Windows or Linux and other kinds of operating systems. Azure Service Fabric is specifically for Microsoft platforms. It's an orchestration tool for containers for only Microsoft platforms, whereas Kubernetes or K8 is a cross-platform, which means for any platform or operating system. Okay, now continue, Sadish.
You don't worry about infrastructure and focus on your code. Which of these services would you recommend? Azure Functions.
And why?
Infrastructure and focus on your code. Infrastructure is like a blueprint which is already available, Navin, I think.
So in Azure Functions, you just write the code. You don't maintain the infrastructure.
Okay, Navin.
Okay, so that is Azure Function. Okay, continue.
You want to build a serverless workflow with a GUI, graphical user interface, involving orchestration of multiple long-running processes. Which of these services would you recommend? Apps. Azure Logic Apps, Navin.
Why?
Graphical interface involving archives of multiple long-running processes.
Okay, Logic Apps says you're building a group of functions. You can think if you have a group of tasks, each function can be a task and a group of tasks or functions are built, and you want to connect them. That is what the logic apps do. Okay, continue.
Customer is responsible for availability when using PaaS. Customer is responsible. True, Navin. Thank you.
No, I think it's a false. When you use SQL Server or any database, you're just writing the code. You're not taking care of the availability. That is taken care of by the cloud. That is what this PaaS is about. Okay, next one.
In PaaS, customer has access to VM instances. False, Navin.
Why?
Platform as service, customer do not have permissions, I think so.
Good. They don't have access to the VM. They have access only to the database or the software. Okay. Continue.
Your application needs customized OS and customized software install. Which of these services would you recommend? Azure VMS, Azure App Service.
It is the VMs. In VMs, you can install whatever operating whatever software you want. You can also customize the operating system. In app service, you only customize, you only deploy the web applications. Okay.
Okay.
Next one.
Hot tier is recommended for frequently accessed data in Azure blob storage. True, Navin.
Frequently accessed, yes, that is hot tier. Okay, next one.
Data stored in Azure blob storage used Azure tier should be rehydrated before you can access it. Rehydrated. Don't know, Navin.
Yes, you have to rehydrate it, which means rehydrated means in archive generally you store the infrequently access the data, you store the data which is not accessed. So when you rehydrate it, it's you're going to the archive servers and telling it I want the data, it will take some time bringing it back. That is what is called rehydration. So you have to rehydrate it. Okay, next one.
Data stored in Azure storage locally redundant storage is replicated across multiple availability zones. True, Navin.
In locally redundant storage is replicated across locally result. I think this is a false.
False. I think I thought.
Okay, that's a false because locally redundant means you are locally replicating.
Localist.
Next one.
Operational expenditure. Money spent on you use a service or a product. Example, provisioning VMS as you need it. You need them.
What is operational expenditure?
Money that is spent for using a service or a product on a product.
Okay, so money is spent to use a service or a product, provisioning VMs as you need them. So in other words, operational expenditure is nothing but the rental monthly basis. Yeah, more simple answer is what it's some the expenses that we undergo on monthly basis is referred as OPEX. And inbound data from on-premises to Azure is free. Outbound data from Azure to on-premises is not free. So in other words, when we install the servers, when we create the virtual machines and things like that, the first time what we generally do is whatever data is in our company that is on-premise, we try to import it into Azure. That is free. But if any data we are taking from Azure and going back, putting it in our company and things like that, that is not free. Data traffic between Azure services in the same region is free. Again, between multiple regions is not free. That is something to be kept in mind. So Azure Sphere, we have not yet talked about it. End-to-end IoT solution with device tampering detection. It's an end-to-end IoT solution. Everything that you can do in IoT is generally referred as a Azure Sphere service. So the hardware, software, communication, end-to-end security, recommended for high security use cases such as ATMs, point of sales devices, and things like that. ATM is a very, very high security because that's our banking, money banking data and things like that. That's why it's referred as a high security use case. So that's what Azure Sphere is about. Okay. And then we have Azure IoT. It is a managed message hub for IoT devices. Means IoT hub means it is a hub where it is taking all the messages and keeping it there. And what will happen, all these messages will be behind the scenes processed and analyzed, and the insights will be understood. That is again a one-line definition of it. Then Azure machine learning. It is used for building machine learning models. Machine learning is the latest buzzword and the latest and the greatest thing. That's where all the money is going into things like that. They help us understand the insights. So that's where the Python, the R, the Jupyter notebooks, all of those things come into the picture. And guys, I want all of you guys to remember, even though we are focusing on Azure, big data and things like that, on a daily basis, at least half an hour to 1 hour time, or at least half an hour time, if you go back and practice some of the Python concepts and things like that, that will be helpful for you. Later on, again, towards the end, I will be covering some more advanced concepts if time permits. So I want you to keep practicing some of the things that we have discussed, guys. Everybody with me? Quick yes, please. At least half an hour, do practice whatever we discussed in the earlier days and things like that. And okay. So Azure machine learning, it is for building models. We can use any programming language, Python or, and it gives us drag and drop machine learning and automated features for building machine learning models. And that's what we need to keep in mind. Okay. Next, Azure Resources Manager template helps you define resources in a JSON file and automatically provision them across the environments. So this is for maybe business user, maybe for a user who's completely non-technical. What we can do is a JSON file, it's nothing but a dictionary of dictionaries. We can use a template like that. And when we want to build many resources at one time and things like that, the template can be used in building multiple resources, multiple VMs, maybe somebody in testing team, they're not much into infrastructure. So an infrastructure head will create this template and pass it on to them. Whenever they want, they will use these templates and create the resources and things like that, guys. Okay. Azure Dev Test Labs, they quickly provision development and test environment. So we are completely setting up a separate environment for development, separate environment for testing. Development is where all the developers are developing their code and they're doing their testing. The testing or the QA team will go ahead and use a separate environment, not the developers environment, to make sure all the scenarios are working and things like this. So that's where the dev test labs get used, guys. Okay. And okay. So let me see, come back here. We'll save a few of them for tomorrow. And give me one moment. Stop the share. Give me one moment, guys. Okay, sorry about that, guys. Let me bring up. So all these slides and things like that, the questions I'll be sharing with you. What I would ideally like you guys to do is I want you to be able to practice these things and get yourselves ready, guys. Okay. So let's see. We're back here. And then we'll storage types. Okay, I think yesterday we were discussing about the storage types. But before we discuss the storage types, let me bring up this and see if you're able to recall these things. So sharing the screen again. Here, sharing it. Okay. So IaaS, PS, or SAS deploy custom applications in virtual machines. The scenario is we want to deploy custom applications in virtual machines. Is it IaaS, PS, or SAS? What do you think, guys? I'll give you a hand. We have taken the virtual machine and we want to deploy something. Custom application. Okay, let's see what that is. That is IaaS. Infrastructure. So we have taken the virtual machine means, and virtual machine means machine means infrastructure. So that's infrastructure as service. Is Gmail IaaS, PS, or SAS? What is Gmail? It is SaaS. That should be a straight one. Using Azure App Service. Is that, which one is that? It's PaaS. Okay, because in us using an app service, we will deploy multiple web applications. Then customer is responsible for OS updates when using PaaS. True or false? What do you think? Is customer responsible for OS updates? I think it is a false. It is a cloud. We just are using the SQL database or whatever the database or the other platform, but we are not updating it. Customer is responsible for availability when using PaaS. True or false? That's a false. Yesterday we discussed all these things, but one more time I'm just going over them for your benefit, guys. In PaaS, customer has access to VM instance. True or false? I think that's a false. We don't access the VM. In only IaaS we have access the VM, guys. Okay. In PaaS, customer can customize OS and install custom software. True or false? You can install custom software in PaaS. I don't think so, guys. It's a false. In PaaS, you don't. In PaaS, customer can configure auto scaling needs. Tough one. What do you think, guys? You have taken SQL server and now you're saying you want to scale you want to configure the scaling. Oh, it's a tough one. The answer is true. Even I am a little in thinking about that one, but it looks like that's a true one. Okay. And in PaaS, customer can configure hardware needs. You're given the database and now they're saying, can you configure the memory? Can you configure? They're saying you're trying to configure the memory and the CPU. I think that's a false. In PaaS, customer can configure hardware needs. Interesting. I think that should be a false. Maybe that should be an IaaS, I think. But it's given as true. I may need to go back and check that. Okay. PaaS services only offer compute services. What do you think, guys? Processing. I think that's a, oh, for a moment I thought that's a true. That is also, so the last two things, even I'm getting them wrong. Compute services is many things are compute services, not just the process. Compute means purely processing. But Azure App Services, apart from Azure App Services, there are many other services. All of them don't come under platform. So I think that is why it is given as a false, guys. Okay. And there it is, guys. Azure Services, VMs, App Service. Azure VMs is nothing but Windows, Linux. We can use both of them. Use VMs when you need control over operating system or you want to run custom software. You want to handle availability, scalability, load balancing software, all these things, we use VMs. An app service, you want to deploy the web apps, mobile backends, RESTful APIs, built-in auto scaling and load balancing. Is again a platform as service. Container instances is also platform. So container as a service, CAS, run isolated containers without orchestration. So container instances running one instance at one time. Kubernetes is running a group of containers at one time. They are cross-platform. Azure service is Microsoft specific. You package, you deploy them. and it's a Microsoft specific containers. Azure Functions is serverless. Everybody okay with this slide, guys? We discussed yesterday, but I'm just reviewing it one more time. Quick yes, please. Okay. Then we have the storage. We discussed the block storage is nothing but the disks and things like that. Then we have file storage and object storage. Block storage is the hard disk. File storage is your network drives. Object storage could be your records, your databases and other kinds of things is object storage. So managed cloud storage. Remember, managed means it is managed by Azure. They are giving us a high availability, durability, massive scalability, up to petabytes of data. 1 petabyte is 1000 terabytes, one terabyte is 1000 gigabytes. I'm sure you all know what is a gigabyte, guys, okay? And so in other words, in managed, the cloud is taking care. Azure Disk is block storage. Azure Files is your network drives. Blobs, again, can be unstructured data. And Azure Queues is for messages. For now, you just remember Azure Queues is for messages. It is slightly advanced, maybe at this stage for you to understand the queues, but we'll see if we can discuss. Azure Tables, we have both structured data and unstructured data also. For unstructured data, semi-structured data, we use NoSQL. We briefly discussed about HBase, the columnar storage and things like that. We'll talk more, guys, okay? So storage account is needed for Azure Files, for all these kinds of things. That is where we are having an issue. Right now, we're unable to create that storage account. So that's why we're unable to access that one, guys, okay? Next, locally redundant. 3 copies are stored in the same data center. Zone redundant, 3 copies in 3 zones in the primary region, in 1 region, in 3 zones. Geo redundant storage is LRS plus asynchronous copy to secondary region, 3 more copies. So 3 copies locally, 3 more copies to a secondary region, another region. Geo zone redundant means ZRS. You're storing in multiple zones and multiple regions. It is the most expensive thing. Everybody okay with the slide, guys? Quick yes, please. So you don't have to by heart them, but if a question comes up like this, then you need to be able to give a thought and put your best into the question and try to answer that one, guys, okay? So again, block storage, the hard disk, 1 block storage, 1 hard disk to 1 server. We can connect multiple block storage devices to 1 server also. So a group of disks can act like 1 server is what you can think of, guys, okay? And disk storage, again, we discussed this also. Disk for Azure VMs, standard HDD, SDD, premium SDD, Ultra SDD. The Ultra SDD will be the most expensive thing. Managed versus unmanaged. Managed is taken care of by the Azure cloud. Unmanaged is not taken care of by them. We have to take care of them. That is much more difficult, guys, okay? Managed disks are easy. High fault tolerance and availability. Again, the cloud is giving you very high availability, whereas unmanaged, we need to take care of them. Block storage, again, I think we just talked about this, the same thing again. Unmanaged disks are old and tricky. Avoid them if you can. Generally, we don't use unmanaged disks unless it is and until it is for very specific purposes, very less critical things and so on. And generally, the architects or the network administrators handle them. We don't handle them, but you just be familiar with what is managed versus unmanaged. Files is nothing but your network servers. Media workflows need huge shared storage. In other words, sometimes we need huge files to be shared from one computer to another computer. So you cannot put them on a computer, you put them on a server. And these are very large files. You try to work on them using the server only. So a large video, very big video is on the server. It's unable to fit onto your computer. You can think of it like this. Enterprises users need a quick way to share files. It's again, you're quickly sharing the files by putting them on the server, not on your computer. If you're on your computer, then others may not be able to access it. But if it's on the server, you generally give access to multiple people, guys, okay? So Azure files, they are managed. You can connect from multiple devices. That is what is advantageous. Everybody can share. This supports server message blocks and network file system protocols. Again, that's more at an operating system level. But the use cases you're sharing it in different computers, different virtual machines and things like that. That's where we use Azure files. The Reason we are saying Azure is it's managed. Okay. Then the blob storage. Blob storage is for unstructured data. Object storage. You can also store structures. Containers are also generally stored in the blob storage. They store massive volumes of unstructured data, the text, the video, audio, and things like that, the media files, the backups of your databases. These are very, very huge. 3 types of blobs. Blob means big, large object. Blob, it is stored text or binary files. That's for videos and text files. Append blob, store log files. Log files are generally appended. Today's log file, if you want to save tomorrow's log file, you will not modify today's log file, but you will add it. That is called appending. Page blobs, again, it's more of an operating system level. It's more used in infrastructure as service, but I guess we don't need to go into that level. Then we have Azure Data Lake Storage Gen 2. This is for big data, very, very huge amounts of data. Azure Blob Storage Enhanced. So data lake is like a big data setup in a slightly friendly way. So designed for enterprise big data analytics. That's where the Hadoop, Spark, all those things come in. And they are low cost because they're internally using commodity servers. They have again tiered storage, the hot, cold, archive. And we can get the high availability and the disaster recovery options. We'll discuss about them, guys, okay? So tiers, different kinds of tiers can be stored. Media files, website static, backups, long-term archives. So huge variations in access patterns. What is access pattern? Again, pay a cheaper price for objects we access less frequently. So in other words, it's nothing but the hot, cold, and the archive. Hot is frequently accessed data. Cold is less than 30 days. Anything greater than 180 days, you're not accessing it. That is generally archived. Archived is lowest storage cost because you're not accessing it much. And if you want to access it, it is taking a few hours. You have to go through a process, or it is internally going through a process and getting some data. And that process is nothing but rehydration. Change access tier to hot or cool, or a copy to another blob with access tier or hot or cool, which means if something is an archived tier, we can also change it to cold or hot tier if we want. To access rehydrate, change access tier. I think that is also called as rehydration. Rehydration means you're changing it from archive to cold or archive to hot. So as long as you have an idea of what is hot, cold, and archive, that is enough, guys. You can change access tiers at any point of time. So again, that is the same thing as what that is. Everybody okay with this slide, guys? Quick yes, please. Okay, we can take a few minutes and we can take a break here. So databases, back to fundamentals of databases, but at a slightly at a higher level, we'll go. We have earlier looked at all the basics of SQL and things like that. This time we'll more focus on the database, high level concepts, guys, okay? Architectural concepts and things like that. So databases provide organized and persistent storage for your data. In other words, structured data. You know the metadata. Metadata is nothing but the column data, column names, column types, data types, and things like that. To choose between different database types, we would need to understand availability, durability, and so on. So let's see what that means, guys, okay? Imagine a database is deployed in a data center in London. So back to London, we are deploying a database. Consider some challenges. Your database will go down if the data center crashes or the server storage fails. If your data center is down, you cannot access your database. You will lose the data if database crashes. There is some problem in the software of the database. So as a result of that, you're not able to access the data. What is that? That means you lost the data. That's another challenge. What can we do? We can automate. We can take snapshots of the data. What is a snapshot? A picture of the data in the database and save it every 1 hour. So every 1 hour, you have the data. It is acting like a backup. And what can you do? The problem is any data which is in the last 1 hour, that we may not be able to get it. That is a problem. So challenge 2 is partially solved. You will lose the data if the database crashes. you can set up database from the latest snapshot, but depending on when failure occurs, you may lose an hour of the data. That one is partially solved. A new challenge is database will slow down when you take snapshots. So every 1 hour, if you're taking a picture of the database, generally database admins do that. What is happening is that's a huge resource utilization. The CPU and the RAM will get used up, and that will slow down your database. Is a new problem which is coming in. So what can we do? That's where we can use the transaction logs. So what we can do is add transaction logs to database and create a process to copy it over to this second data center. In other words, this is like copying the meta store. In Hadoop, we have a primary name node and a secondary name node. The metadata is getting copied to the secondary name node. That is what this one is. For a database, it has its metadata. Some of the metadata is getting stored in transaction logs. Not only metadata, but also the data is getting stored in transaction logs. This transaction logs every 1 hour. From the transaction logs, periodically, not every 1 hour, every few seconds to few minutes, whatever the data, the latest data in the transaction logs is getting saved to the database. That is what the process is, guys. Okay, so we can add transaction logs, and what is that? That is one way of copying the data or saving the data. Another way is adding a standby. Add a standby. Standby is like a backup in another data center. So now adding a standby solves the first challenge. You can switch to the standby database. If one data center is down, you can switch to the second data center. If we lose data in one database, then we can get the data from the second database. What is this backup? This is like a hot standby, hot backup, which means any times we save one record in this database, in a primary database, behind the scenes, we are going back and replicating that change, adding that record in the standby database. So most of the times, both of them are the current picture of each other. So if one of them is available, we can go back and get it from another one. In other words, the replication concepts that we discussed in the world of big data and Hadoop are now being applied at the concept at the level of a database is what it is, guys. Okay. So now even the third problem is getting solved. If you're taking snapshots frequently, that slows down the database. But by maintaining a standby database, if one of the database is down, or what you can do is the primary database, you always keep it running. The secondary database or the standby database, you keep taking snapshots. As a result of that, the load on the primary database is getting reduced. Everybody with me, guys? Quick yes, please. The primary database can be thought of as a master, and you don't take a snapshot from the master, but on its standby, we will be taking a snapshot. Okay, guys? Okay, so where we are, that's slightly heavy. Okay, gentlemen, ladies, 1:15. Let's take a lunch break, and we'll regroup by 2 and continue from there, guys. Everybody okay with that? Thank you, guys. Niharika, are you back? Lavanya, are you back?
Yes, Naveen.
Can you make me the host, please?
Yeah, sure.
Thank you, Lavanya. Okay, guys, are you back? Can you give me a quick yes, please? Okay, so let's talk a little bit about availability and durability, guys. Availability is, will I be able to access my data now and when I need it? Okay, so in other words, putting it simple terms, your data should be available. Percentage of time an application provides, the operations expected of it. Let's say out of 10 hours, it was only available only 9 hours. Well, that is 90% of the time. Okay, but ideally, that is a very, very low availability. That is not really accepted in an enterprise world or in a real world, guys. Okay, they don't want, the enterprises or the businesses generally do not want their data to be unavailable for a long time. That's why it becomes important. Durability is, will my data be available after 10, 100 or 1000? How long it is going to be available in the future? Okay, availability is a kind of taking in the past and in the present how much of time it was available. Durability is in the future how much time it will be is going to be available is durability. Examples of measuring availability and durability: 4 nines and 11 nines. Typically, an availability of 4 nines is considered very good. The durability of 11 nines is also considered very good. Okay, we'll go a little bit into these two details. Yeah. Okay, so 99.95% availability, the downtime may be up to 22 minutes. Okay, 4 nines means the downtime may be up to 4.5 minutes, and 5 nines is 26 seconds. Achieving 5 nines availability is tough. Okay, generally, to keep our availability high, what is the strategy that we are taking? What do we do, guys? If you want your availability to be high, what we were discussing this multiple times, what were we doing? Can anybody take a guess? Can anybody tell me, guys, what are we doing to keep our availability high? At this stage, it should be a simple answer, or maybe a medium complex one. It should not be very tough one. We are scaling. Scale sets is coming to our rescue. We're making multiple VMs available, and that's how we're keeping the availability high. So what does the durability of 11 nines mean? If you store 1 million files for 10 million years, you would expect to lose one file. That is kind of a definition, a formal definition. Why should durability be high? Because we hate losing data. In a real world, business or an enterprise cannot losing the data is not a acceptable scenario, guys. Once we lose the data, it may be gone. That is why a high durability is required for you, guys. Just durability is, you know, how long it is going to be available is something you want to keep in mind, guys. We don't want to lose the data. Increasing availability and durability, have multiple standbys available or distribute the database. So in a VM world, we are scaling it. In a database world, we are having multiple standbys. A standby database is what we are doing. Or distribute the database in multiple zones, in multiple regions. Again, the database will be in a VM, and that VM can further be scaled out into multiple zones and multiple regions. Okay, guys, so in other words, let's say, back here. So let's say that's our globe, and we have a database here. Let's say in India, we have a database. So what we are doing is we add a standby. In the same data center, we can add a standby. Now, what is this one? This, you can think is in one virtual machine. and the standby, pardon me, can be in another virtual machine. Pardon me. And what is happening? These two are in a data center. What can we do? We can put that in another data center. We can also put that in another zone. We can also put that in another region. The entire stuff exactly looks like that. So now the VM which contains the thing can be scaled out. We can do a scale set, and that way we are maintaining multiple replicas. That is possible, but ideally, maybe maintaining a standby database should be more than enough. Generally, these servers are enterprise class servers. We don't really maintain cheap servers for them. So generally, they don't go down and things like that, guys. Okay. So increased durability, multiple copies of data, snapshots, transaction logs, and replicas. So inside a database, it is internally maintaining a transaction log. The transaction log is where whenever new transactions come in, first they're saved into the transaction log. So let's say they are saved here. And what do? Periodically, what the database does is it takes its data and the transaction log, it merges in the database. Keeps merging in the database. That's how the databases work. And we can also back up we can maintain multiple copies. And replicating data comes with its own challenges. So again, whether you want to just maintain multiple standbys and things like that, multiple snapshots and things like that, these are generally decided at a architecture level, guys. Okay, but for us, we just have an idea of the availability and durability. That should be good enough. So RTO and RPO. Imagine a financial transaction being lost. If it is 1 rupee or $1, that is important. That is very important for the customer who made the transaction. But what if it is $1 million? That becomes very, very more very critical. In other words, even a $1 or a 1 rupee transaction is also very important in a business world. Imagine a trade being lost. Again, the trade could have been just for a few rupees to a few dollars to $1 million. What happens? Well, if you lose it, you lost it. And that will be, that is not a good sign or indication, guys. Imagine a stock exchange going down for an hour and millions of people around the world are into stocks, getting into stocks and things like that today. So what happens? All these guys' work will be impacted. Typically, businesses are fine with some downtime, but they hate losing the data. In other words, losing the data is unacceptable. A little bit of downtime for maintenance is acceptable, but we cannot afford to lose the data. That's why availability and durability become important. How do we measure how quickly we can recover from failure? If at all there is a downtime, there is a failure, there are a couple of ways we can measure. Recovery point objective and recovery time objective. Recovery point objective is maximum acceptable period of data loss. So in 1 minute time, we may lose certain records of data. How much is that period? Recovery time, how much maximum acceptable downtime? So 4 nines, 5 nines, 11 nines we are seeing is one of them is 4.5 minutes, I think. We come back here. Another one is 20 seconds. I'm sorry, 26 seconds. Another one is 22 minutes. How much time we will be down? That is what the nines are. The story of the nines is, guys. Okay. So achieving minimum RTO and RPO is expensive. Achieving both of them is tricky. So generally, we cannot optimize. What we try to do, or what architects try to do, is they try to optimize these two things. What is that they try to? We cannot achieve both minimum RTM and minimum RPO, but we try to optimize. And there is always a trade-off based on the nature of the data, nature of the application that they are dealing with. So trade-off is generally, see, in certain cases, RTO is more important than RPO is what it means, guys. Okay. So we're running an application in VM instance, storing its data on a persistent data storage. We're taking snapshots every 48 hours. If the VM instance crashes, we can manually bring it up in 45 minutes from the snapshot. What is your RTO and what is your RPO? Well, 45 minutes and 48 hours, guys. Okay. So we are running an application in VM. On a persistent data storage means we have a database. We are taking snapshots every 48 hours. Recovery point of, what do we say, objective. Recovery point objective is 48 hours is what we are saying. If the VM crashes, we can manually bring it up, back up in 45 minutes. So recovery time objective is 45 minutes. Sorry about that. Okay, is what we are indicating here, guys. Okay, so let's go dig a little bit deep into it. In scenarios where we have very small data loss, if you need, where we have to have very small data loss, which is RPO is 1 minute, very small downtime, RTO is 5 minutes, we can use a hot standby. Automatically synchronize the data. In other words, anytime a change is made in a database, in a primary database or a master database, immediately go to the standby database, or the change is also being made in a standby. So if the master database fails, the standby database, we have the latest backup available. Have a standby, use automatic failover from masters to standby. So in other words, automatically the request will be directed to the standby. In scenarios where we need very small data loss, but we can tolerate some downtimes up to 15 minutes, warm standby. Automatically synchronize data, have a standby with minimum infrastructure, scale it up when a failure happens. In other words, a hot standby is exactly a enterprise class server. Okay, but a warm can be slightly less. Generally, that is also in database world, we use enterprise class servers, but scale it up means you try to increase. You maintain a server with maybe, let's say, 8 GB RAM. The master is 16 GB, let's say, for the sake of simplicity. In real world, they'll be much higher. So if at all the master goes down, we raise it up, we scale it up to 16 GB RAM, and the other components of it is what we are saying. That's a warm standby. It is also like a hot standby, but it is a scaled down version of the hot standby. And data is critical, but we can tolerate a downtime of few hours. So what do we do? Create a regular data snapshots and transaction logs. Create database from snapshots, transaction logs when a failure happens. This is a slightly cheaper solution. You don't have to buy another enterprise class server. Those are very expensive. Of course, we can rent them, but still we don't go that far. We don't even go that far. That is what we were just going by the snapshots, and snapshot is a backup of the data, picture of the database. Transaction log is in the last 1 hour. Whatever the changes are being made will not be there in the backup. They will be there in the log files. It's something you need to manually keep in mind. Data can be lost without a problem. For example, cache data. Cache data means generally what happens, guys? Let's say here is a database. Start with this one. Here is the database. And generally there's a web server. There's a web server. We get the data. The web server is accessing the data from the database. And here is the clients. The user interface, UI layer is what we call. And here are different kinds of clients accessing. Somebody is using Mozilla, somebody is using Chrome, Firefox, and other kinds of browsers and things like that. They are generally accessing your UI layer. UI layer is communicating with the web server. This is how the architecture is, an entire architecture is. So what we are doing is fail over to a completely new server means, so cache data, to be more precise, what it means is data is generally here. Okay, data is here. Data is being returned by the database to here. When a request comes in, data is returned by the database. But sometimes what we would like to do is, for very high performance and things like that, we can cache the data. You can take a part of the data or full data. Generally not the full data, but part of the data, the important parts of the data, you keep it in the RAM of this one. And what do? Rather than when a request comes in, don't go to the database and get it, but right away return from the RAM to your UI layer. So as a result of that, you get high performance. But what can happen is sometimes due to some reason, the RAM may get into a problem. the RAM gets cleared, the machine gets restarted and things like that. So what you do, you reload the data. And what is this? This data is referred as cache data. This data is referred, it's caching isn't, you're maintaining it in the RAM. Failover to a completely new source. So in such a stage, ideally, imagine we have a scale set behind the scenes. What's happening is we have another virtual machine with similar kind of setup. So using scale set, and this one will be exactly maintaining the data in RAM. So now the request will get redirected here. The request will get redirected here rather than that one because this went down. Maybe the RAM is down or maybe something happened in that host. That is what is the third scenario. Data can be lost. We are not actually losing the data, but it's actually the data which is in the RAM, which is in the cache is lost. So you fail over, you reroute it to a new server and then you try to start the process and things like that. Everybody with me guys, quick yes please. Everybody okay with the slide? Okay. Next, let's say consistency. Now these are the high level architectural terms and terminologies from a database standpoint of view. So let's see if we can simplify it. Consistency, how do you ensure the data in multiple database instances, standbys and replicas is updated simultaneously? Okay, so whatever data is coming into your master database, ideally what will happen is they're syncing it up with the secondary database. So what is that? Strong consistency. Synchronous replication to all replicas will be slow if you have multiple replicas or standby. So you have one standby here. And sometimes for mission criticals, you may want to maintain multiple databases in other parts of the regions of it. So every time a change happens here, you need to also make the change. And what is this? This is what is called consistency. You're maintaining all the databases consistently. Synchronous replication to all replicas will be slow means when a change happens here, at that time you're making the change and you're waiting until the change is done. That is synchronicity. Okay, so in other words, to understand that asynchronous replication, a little lag. In other words, what that means is when a change comes in, here, what you do is you just broadcast it. You tell it, hey, I have a change coming in, you make the change and you give it time. You don't wait for it. You broadcast here, and you're not waiting for the response. So that is asynchronous. You just post it and leave it. So it will take a little time before the change. So what is happening is this is referred as eventually. Eventually means that by the end, in a matter of here in strong consistency, immediately it's happening. Here it may happen after a few seconds. What is that? All the databases are consistent. After a few seconds or after a few minutes, that is okay in certain scenarios and things. That is referred as eventual consistency. In the intermediate period, different replicas might return different values. So in other words, let's say a change came in. So change came in and now it broadcasted it here. The change is made here. And now it is still broadcasting to this one and broadcasted to this one. So now what happened is only 3 of them have the change and 1 of them does not have the change. That is inconsistent. It is still taking time due to some reason. The request is not yet broadcasted or not yet saved in this database data time. So in the intermediate period, different replicas might different values. So if at all a request goes to this database for some reason, okay, it will say, hey, it is the change, I don't have that change. So used when scalability is more important than data integrity. Scalability is, you want a lot of databases to be up and running and you want them to be performing fastly and things like that. That is scalability. A little bit of data integrity means you say Divya's name is the Vidya. That's a small and a subtle change, or maybe that's a big change, but just for the sake of simple, that is data integrity. Divya's name should be saved as Divya, not as Vidya. Example, social media posts, Facebook status messages, tweets and things. These are nothing but opinions. Divya went to a Starbucks coffee shop. She liked the coffee. She tweeted that, hey, the Starbucks coffee is good. It is possible that the tweet was saved successfully, or it is possible the tweet was there only in some databases and it got missed. That is what is that? That is an example of data integrity, data inconsistency. Next, read after write consistency. Inserts are immediately available. However, updates are would have eventual consider. So if it is a new request, let's say, if it is a new request, immediately you go ahead and update everything, insert everything. But imagine it's an update, which means, let's say, choose this one. It's an update means you're modifying something. So what will happen? Modify will not immediately synchronously do that, but it will do it asynchronously. It's a combination of both of them. Updates would have eventual consistency. So strong consistency is you need to make the change right away and you wait until it is done, because when the response is received, it will make a note, hey, this is done. That's how it knows that is consistent. Eventual is you're just passing it on, you give the job to somebody else and you do your job, you do your stuff. That is eventual consistency. Everybody with me, guys. Everybody with this slide, guys. Quickest, please. Okay, these are very deep topics of our database at an architecture level, but if you have a high level understanding, that is enough, guys. You'll be coming across these terms here and there in a NoSQL world. At a working level, you probably they will expect just a familiarity, but database, a key value database, a graph database, an in-memory database. These are nothing but the NoSQL databases. And in-memory databases are object databases. This is traditional relational databases. Choosing the type of database for your use case is not easy. In other words, who will choose? Generally, it's an architect who is choosing the database. Whether you want to use a relational database or whether you want to use a NoSQL or an object database, an architect will choose, not us, guys, okay? Or not you. Do you want a fixed schema? Fixed schema means in relational databases, we create the tables, the column names, the data types upfront. Very rarely we make changes. Whereas in the world of NoSQL, most of the times, your tables are modified at runtime. Your tables, based on the data, you create the tables. So there, the schema is not fixed. We'll try to understand a little bit about that, guys. The schema is variable. It's called variable schema. Again, that's an architectural decision. What level of transaction properties do you need? Atomicity and consistency. So we talked about consistency. Atomicity is again at a record level. You're making inserts and updates and deletes. That is referred as atomicity. So so in other words, what consistency do you need? Do you need a strongly consistent database or an eventually consistent database? Those things come up mostly in a NoSQL world. So for you guys, you just hear me, get an idea, and we'll try to look at a few examples. What kind of latency do you want? Is seconds, milliseconds, or microseconds? If you have 10 or 20 records, you're saving to you can save it to a database. Hundreds or thousands of records also you can save it to a database per second. But let's say you're expecting millions and millions of records per second. That's where the NoSQL comes into picture. So how much delay you need? How many transactions do you expect? Is it tens, hundreds, thousands, millions? How much data will be stored? Megabytes, gigabytes, database is enough. But once you touch terabytes and petabytes, that's where we will go towards the NoSQL world. These two scenarios, we are heading to the NoSQL world. Is generally. So again, what are these? These are at an architecture level. So what do? We have different kinds of databases. Relational database. Cosmos is a NoSQL database. Then let's see, what is this one? This is an Azure SQL database. And so these are the different, this Postgres. This is Postgres, this is Azure database. That's what we'll talk in a bit, guys, okay? So let's see, relational databases. This was the only option until a decade back. So until 10, 15 years back, most of the time, everyone by default, if they need a database, they will use a SQL server or an Oracle database or a MySQL database. They are the most popular, but you need to define the schema. So in other words, the architect needs to build all the tables, all the schema needs to be given. They're very strong transactional capabilities. The objective is to store the data. The objective is to save the data. Imagine there is a cricket match tomorrow. and we have the data of last 10 or maybe 100 cricket matches of data. What we need to do is we need to store all the players' names, the countries, the matches they played, how many runs, how many wickets they scored, and things like that. That is transactional data. You're inserting the data, you're updating the data. That is online transaction processing. If you're inserting and saving the data. But many times what we do is we try to analyze the data. Analyze is you take all the data from multiple databases, multiple sources, you save it into an OLAP, a data warehouse. That is like a group of databases. What do you do? That is like a super database. You try to analyze. In the last 10 matches, who played well? Who are the best bowlers? Who are the best batsmen? Which combination of the players are playing well? I think if you take a look at this, what is this IPL 2020? There is this the mobile game. Everybody keep playing. I don't know if you guys keep playing. They bet on these players. They bet these things. What is that, guys? Do any of you play that game? Dream 11, something like that. So they are choosing their own combination of players. And what is that? All that is AI behind the scenes. That is nothing but an analyzing. When you analyze the data in a database or a data warehouse, it is referred as online analytical processing. That is again structured data. When you analyze structured data, that is analytics processing. When you analyze unstructured data, that is nothing but the big data analytics is what it is. Okay, so let's dig a little bit deep and try to understand each of these things. So here is online transaction processing. Applications where large number of users make large number of small transactions. So as I said, imagine you have a database and what you want to do is you have cricket matches data. You have to save all the cricket players in a separate table, all their matches in a separate table, all their countries in a separate table. What is that small? Those are small records of data. You save the data. First you insert the data, then you update the data, then you delete the data and you try to access the data. That is reading the data. Most of the times the applications, traditional applications use, start with the relational databases. These are the popular databases, MySQL, Oracle and SQL Server. And we have Azure Managed Services. Azure SQL database is SQL Server. Managed means again, the cloud provider, Microsoft or Azure is taking care of. They also give us MySQL. They've also given us PostgreSQL, and we'll see how to access them in the coming up days. And here is SQL Server database. So fully managed for Microsoft SQL Server. They are taking care of the complete thing. They are promising us 99.99, 4 nines availability. 4 nines, I think, is 26 minutes, I think, downtime. It has high availability, automatic updates and backups. So everything is being taken care of by the Azure. Flexible and responsive serverless. More importantly, it's serverless. We will only pay for how much time we used. If it is idle and empty, we are not paying. Serverless, that's a big thing. Hyperscale, it can go up to 100 terabytes. That is more than enough. For database with 100 terabytes is generally very, very huge. And generally, I mean, it doesn't really grow up to that one unless you're working with the Yahoos and the NASAs and organizations like that, guys. Okay. Then they're also giving us MySQL. So I come here. So fully managed scalable MySQL database. Again, it is fully managed. It is scalable. It's MySQL database. Different versions are supported. High availability. You can choose zone redundant, high availability. Again, similar to SQL Server, they're giving everything. Typically, the MySQL is used with Linux, Apache, MySQL, and any of these programming languages is what is generally referred as the LAMP stack. So in other words, it is same. They're giving all the features same as SQL Server for MySQL server, and for PostgreSQL also, all of them are same. Again, it is more intelligent and scalable. So in other words, it is especially more useful in the scenarios of the big data. High availability, redundant, zone redundant, high availability, and hyperscale options. Scale to hundreds of nodes and execute queries across multiple nodes. This is in big data scenario. You generally don't have SQL Server or MySQL when you use hundreds of nodes. When we need hundreds of nodes, we come to PostgreSQL. It is using the principles of Hadoop. and it is saving the data to multiple nodes, bringing the cost down and things like that. That option is also available in Azure, guys. Okay, why this is important for you guys is the architects will be using it. Imagine you're sitting with an architect and he's saying he's using Postgres SQL, and he's saying, hey, we can scale up to 100 nodes and things like that. You should be comfortable. You should not ask him what is Postgres SQL, what is how does it work, and things like that. What is this 99% availability? What is scalability? These are the questions they don't like you to ask. These are the questions you can ask them, nothing wrong, but you have to be familiar. You be familiar and ask them. In other words, if they explain once or twice, you should be comfortable with them. If you're totally lost, then that is what they don't want to be. Everybody catching the point, guys? Quick yes, please. So here is generally the way we create it. And let's say, what's this one? Like here. Oops. Okay. So back to analytical processing, guys. So today, data analytics is a big talk and things like that. That's where Synapse Analytics is coming into the picture. So relational database. So OLAP means online analytical processing. Applications allowing user to analyze petabytes of data. 1 petabyte is 1000 terabytes. That is very, very huge, guys. Okay. So reporting applications. You want to create an application with lots and lots of reports. That's where data warehouse come into the picture. Traditional databases are used for small reports, but when your applications, large enterprises have large reporting applications and things like that. In such cases, they use data warehouses. A data warehouse is like a super database. It's like a data from group of databases is plugged into one data warehouse, and then they generate reports. Business BI applications, business intelligence. They're trying to understand what is the intelligence of the business, what happened, why it happened, and things like that. It focuses more on the past. And they try to analyze the data. That is data analytics. Data analytics focuses more on the future. Business intelligence focuses more on the past. Sample application decide insurance premiums analyzing data from the last 100 years. So imagine we have the data for the last 100 years. What should be the premiums? What do? We analyze the data. In such case, 100 years of data is very, very huge. That is what goes into something like a super database called data warehouse. Data is consolidated, which means it is brought from multiple sources, or more precisely, multiple databases. That's why we are saying it's a super database. It acts like a group of databases. So again, Azure has something called Azure Synapse Analytics. It's a petabyte scale. Again, that's very, very huge. Data warehouse provides a unified experience for developing end-to-end analytics solutions, data integration, big data analytics, and things like that. So this is kind of what Hive is. Kind of like what is Hive is what you can think of. Hive, of course, can be a little bit more than this one. So it enables massively parallel processing, means just like Hive and Hadoop parallel processing is inbuilt into it. We don't have to write it. We can write complex queries across petabytes of data. In other words, very, very big data. Earlier, it was referred as Azure SQL data warehouse. So earlier it was called SQL data warehouse. Now they're calling it a Synapse Analytics, guys. Everybody okay with this slide? Quick yes, please. So for you, remember, a data warehouse is a group of databases. Okay, let's see what is OLTP versus OLAP. So OLAP and OLTP are similar data structures. They are databases only at the core, but very different approach in how data is stored. Okay, in row storage, we store the data in the form of rows. In traditional databases, every record. But in the world of a data warehouse, let's say columnar storage, is also okay. In other words, more precisely, it's a denormalized data is what it is. But let's see, OLTP databases use row storage. Each table row is stored together. This is traditionally what we see in database and efficient for processing small transactions. OLAP databases use columnar storage. Each table column is stored together. And again, like in SQL, NoSQL that we discussed in HBase, the advantages is high compression at a physical level. We're able to compress the data, we're able to distribute the data. Executing single query across multiple nodes will enable parallel processing. All these advantages are, we get them. So these are again kind of similar to the advantages that we get in the world of Hadoop. We are now getting in the form of a database, which is a data warehouse, is what it is, guys. Okay, so one of the fundamental things is if you take Hive, Hive can also store unstructured data. Whereas in Synapse Analytics, in online analytical processing, or lab, more precisely here, we do not store unstructured data. We only store structured data. If the data does not have unstructured data, then we cannot use OLAP. Is one quick way to remember that is what it is. Everybody okay with the slide, guys? Quick yes, please. Okay. Okay, then comes the NoSQL, the HBase world and things like that we looked at earlier. We briefly looked at. So it's a new approach. Building your databases. NoSQL stands for not only SQL. It's not that it's against SQL or something, but it was not primarily using SQL. So they said it is not only SQL, you can also have other ways of querying the data. Flexible schema means here the tables are created, tables and columns, column families are created on the fly. Structured data the way your application needs it. So in other words, here also we are saving structured data. Let the schema evolve. Schema evolve means we can change the schema at runtime, change the tables, column names, add more column families and things like that. Horizontal scale to petabytes. Now this is where the big data is coming to the picture. When you're in the world of NoSQL, you're touching the world of big data. Or your architect generally is touching the world of big data. Yes, millions and millions of transactions. They can do millions and millions of transactions per second. Now, if you want to do millions of transactions per second in a database, that will be very, very expensive. Is what it is. Here, it becomes much more simple and easy. Not 100% accurate generalization, but a great starting point. Typical NoSQL databases trade off strong consistencies and SQL features, and to achieve scalability and high performance. In other words, they will give more scalability and high performance and try to be a little bit easy. It is not that they're giving up the consistency. They take it a little, they give it slightly second preference, so second priority to consistency and to the SQL-like language. Today, most of the NoSQLs are also supporting SQL-like language, but in the beginning years, they were not giving SQL. They came and said, hey, we are not giving you SQL-like language, but it is a database is what they were explaining. That's why NoSQL came. They had their own way of inserting the data, updating the data and deleting the data. But of late, they have added multiple packages, guys, which are almost everybody gives you. When you write the select commands, you're able to query the data in your own way and things like that. So again, Azure NoSQL database is Cosmos DB. Azure Cosmos DB. This is like the HBase version of the Microsoft is what it is. Everybody okay with the slide, guys? Quick yes, please. Okay, let's go a little bit deep into it. And see where we are. Okay, Cosmos DB, fully managed NoSQL database. It is a NoSQL database, global database, automatically replicates. So it is taking care of the replication across multiple regions. It is schemaless, which means we can start with creating one table, one column family. We can dynamically add hundreds and thousands of columns and column families or tables. It's like saying generally a database will have anywhere 50, 100, a data warehouse will have something like a 50 or maybe 100 tables or maybe 200 tables or things like that. But here in the world of NoSQL, you can have millions of tables. The table, the data itself is acting like a table. And the table itself is acting like a table. So we can have millions of tables, guys. That is what is important. So single digit millisecond response time, they can be extremely quick. 5.9 availability. And automatic scaling, just like the scale sets, they are scaling. And here one advantage is Cosmos DB is for serverless. And that can be very saving a lot of costs and expenses for businesses and enterprises, unnecessary expenses. When you don't use it, don't pay. That's where the magic lies. That's what attracts them to the Azure or the cloud world. Supports for API, MongoDB, Cassandra. So MongoDB is referred as an NoSQL, a document-oriented database. Cassandra is called a key value database, and Gremlin is called a graph-oriented database. It saves the data in the form of graph. Anything is saved in the form of graph. Here in Cassandra, everything is saved as a key and a value. And MongoDB is saving everything as a document. These are the NoSQL is what it is, guys. Everybody okay with the slide? Quick yes, please. Okay, the last one is in-memory database. And since it's getting a little heavy, let's take a short 5-minute break here, guys. I need to drink a glass of water. Okay, guys, I'm back. Are you back, guys? Can you give me a quick yes? Can you give me a quick yes, guys? Okay, thank you, Shravya. So let's talk a little bit about in-memory databases, guys. Okay, so in-memory database is a cache database. Retrieving data from memory is much faster than retrieving data from a disk. Okay, in other words, generally a database, let's say, come back here. So this is, imagine a virtual machine or a physical server, and there is a database. And this database generally, behind the scenes, is saving the data, which is this, in the form of files. Behind the scenes, there are some files. So when a request comes in, goes to the database is actually going to the files, reading the data, and giving back the response. That's how it works, okay? Now, what is a cache database? We can kind of take the data, put it in the RAM. There are a few databases which put all the data in the RAM. And as a result, what is that? That is referred as an in-memory database. The data is in the memory, so it is called as an in-memory database. So Redis is an example of an in-memory database. It maintains all the data when you need very, very high performance. Microsecond latency means very, very less delay. By strong persistent data in memory, that's when we will use Redis or in-memory database. So Azure Cache for Redis, that's a managed service, again taken care of by the cloud. It is caching the data. The process of saving the data in the RAM is called caching. It takes care of the session management. So in other words, session management, gaming leaderboards, geospatial applications, those are the use cases where we can use a cached database, as simple as that. For you guys, all you need to remember is the data is now available in the memory. So you don't have to go to a file and read the data. It's just returning it right from the memory. As a result of that, it is very, very faster. Everybody okay with the slide, guys? Quick yes, please. Okay, so let's say databases. These are the different kinds of databases that we have and we have discussed. So relational OLTP, this is the traditional databases, the SQL, the MySQL, the PostgreSQL, and they are referred as the transactional databases. The records are being inserted into them. They're referred as the transactions. They're very strong transactional capabilities. Okay, that is transactional database. Then comes this Azure Synapse Analytics, which is an online analytical processing database, or more precisely a data warehouse. Internally, it is columnar storage, storing the data in the form of columns rather than rows. We briefly discussed in HBase Word, and it is referred as a data warehouse. It is also referred as a big data warehouse. In other words, it is like a competitor of Hive. But the only difference is Hive can also take unstructured data. In this one, generally, we only maintain the structured data most of the times. Cosmos DB is no SQL database. It is your answer, Mike. It is kind of the competitor of the HBase. And this is schemaless. Something we need to understand is schemaless means the tables can be modified at runtime. So in other words, the data is stored not only in tables, but the data itself is becoming a table. You can think of the record is acting like a data here. That is, so in other words, every record may be different, and that is what it means by schemaless. There is no schema. There are different ways Cosmos DB can be used. It can work with MongoDB and make it look like a document-oriented, key-value, or graph-oriented database. In-memory databases, again, we just discussed, these are nothing but the data is stored in memory. So as a result of that, we need a microsecond response. It's very, very fast and quick response and things like that. In the world of trading and things like that, that's where we would use a Redis database, guys, okay? So a few scenarios here, let's see. A startup with quickly evolving schema, table structure, we can use Cosmos DB. Quickly evolving schema means the schema is changing. That is NoSQL database. Single digit millisecond response times for global application with millions of users, again NoSQL. Single millisecond with millions of users means millions of records. That's when the NoSQL beats the other databases. Transactional local database processing thousands of transactions per day. If it is thousands of transactions, you can go for SQL database. If it is millions of transactions per second, we go for Cosmos. And cached data, we have to manually remember it is analytic. It is Redis database. And for analytical processing, I will force you to remember the Synapse Analytics. Okay, guys, everybody okay with the slide? Quick yes, please. Okay, let's talk a little bit. We have briefly talked about the networks and things like that. Let's revisit them and see what we have. Okay, in a corporate network or an on-premises data center, can anyone on the internet see the data exchange between the application and the database? No. Who can see the data which is getting exchanged between application and data? Well, very few people. The application should be able to see it. Or that's a very specialized scenario. If you want to really look at the data, you should not be able to see the data. Can anyone from internet directly connect to your database? No. We should not allow others to connect the database unless they know the user ID, password, that is the credentials or the connection string. We need to connect to our corporate network, then access our database. Corporate network provides a secure internal network. What is a network? A group of computers. And corporate is giving us a group of computers protecting your resources. In other words, they're secure. They're secure, they're only used by us, they're internal. Data and communication from external users is also secure. It is prevented, only a few people are allowed to access our network. How do we create our own private network in the cloud? Well, that is what is Azure Virtual Network. Instead of creating a network in your company and taking care of all the headaches, leave it to the cloud. What is that? That is a network on the cloud. It is that's why we call it as virtual. It's coming from Microsoft, so we call it as Azure. And Azure is nothing but cloud. I think the meaning of Azure is nothing but cloud in some Greek or something like that, guys. Okay, that's what it is. Virtual network. Network in the cloud is virtual network. So what is this Azure Virtual Network? It's our network in the cloud. It's isolated, means not everybody can access it. So we are more secure. Network traffic within a network traffic is isolated from all other networks. Again, that's security. You don't want others to see your traffic, your data. Each virtual network is created in a region. And okay, so each region has multiple networks. You control all the traffic coming in and going outside the network. We can again specify the rules and things like that. Create all your resources within a virtual network. In other words, when we create a virtual machine, what is happening is behind the scenes of storage is creating. We can create databases. We'll see how to create the databases in the coming of days and other kinds of computes. Okay, what do? They are allowing us to do everything on the cloud, and so we don't have to do it. The other headaches will be not there, the other headaches of maintaining them. Secure resources from unauthorized access. What do? We need to manually take care of that, but now we can leave it to cloud. Enable secure communication. So again, leave it to the cloud. So all the security is being taken care of by the cloud provider. You don't have to worry about the network. In a matter of few minutes, you have a virtual, you have a network ready, you have computers ready, you have virtual machines ready. Everything is ready. We are paying less, and it is a most optimized way. We are not unnecessarily spending the money on these things, guys. Okay. So next, need for subnet. Subnet is a part of a network. Different resources are created on the cloud. Each type of resource has its own access needs. So subnet for HR department, another subnet for marketing department. You don't want one department to be looking into other departments' files and resources. That's where the subnets come in. And load balancers are accessible from internet. Again, we have talked about load balancing. If it is necessary, we can also do load balancing. databases or VM instances should not be accessible from internet. So now internet means outside. Outside people should not be able to access your database, should not be able to access your VM, because that is the business data. Only applications within your network should be able to access it. Those are private resources. Anybody within the company should be able to see our data. How do we separate public from private inside a virtual network? Well, create different subnets. Again, we don't need to create these things, guys. These are more of a networking thing, but just be familiar with network, virtual network. These are the terms we need to create. The networking team generally is taking care of creating the networks and the subnetworks. Resources in a public subnet can be accessed from internet. If it's a public subnetwork, then outside people from internet, you can access it. In a private subnet, you cannot. But resources in a public subnet can talk to resources in private. So the subnets can talk to each other internally, is what it means. Okay, so subnet is a new term I'm introducing. It's like a part of a network, is what you can think of, or what you need to keep in mind, guys. Next, let's see. Every VM in a VNet is assigned a private IP address. So every VM, every machine has a private IP address. You can assign a public IP if you need external communication. If you need to communicate with the outside world, VMs in the same VNet can communicate with private IP. So VMs in a network, the virtual machines can use the private IP and communicate. Even if they are different subnets, you can use a private IP address to communicate. Network peering can be used to connect resources in different virtual networks. Different virtual networks is, we're a very big organization, and under our organization is a coffee shop. We also have a cloth showroom here. So the administrator builds one network for the coffee shop, another network for the cloth showroom, and now we want to communicate. We want to be able, these two networks to be able to communicate means we want to be able to connect the computers here from here and vice versa. So what is it? That is nothing but network peering. Peered virtual networks can be in different regions also. So this is maybe in USA, this is maybe in Australia. Even then, we can have the networks communicate with each other and access the resources and things like that. Okay, that is a little bit about virtual network. Next, a little bit about network security. So bear with me, guys, a bunch of theory. In coming up days, we'll get into a few labs and things like that and try to do some of this stuff. So DDoS attack. So denial of service, it is generally referred as large scale attacks to bring our apps down. Somebody's trying to hack into our servers, make our server slow. If they send too many requests, what will happen is our server becomes slow. And what can happen? That can create other problems. The bill can increase, unlimited auto scaling. In an effort to try to increase the performance, the cloud may try to keep on adding more and more resources. And what is happening is the bill is going to increase huge. It's going to be very, very big. So two Azure offerings. One is DDoS protection basic, another one is standard. Again, these are also slightly at high level. We'll look at them. So the basic is intelligently identify and block the attacks. This is enabled by default, no cost, which is a good one. And if you want a standard, a slightly higher one, mitigate 60 different types of attacks. So again, this is generally, if you're a small business, we generally go with the basis. But if you're a very mission critical, a financial organization and things like that, then we take something like a standard where different kinds of latest attacks can also be handled, and provides attack analytics. Attack analytics, metrics alerting and reporting, again, can be analyzed. We can take the data, we can analyze. They also provide some analytics on that. So quick support from protection rapid response team, DRR, rapid response, DDoS protection rapid response team. And get a cost guarantee, enable it on a Azure virtual network. So again, this is more of a slightly a premium or a next higher level of the protection for the denial of service is something. And that's as much as we need to know, guys. I don't think we need to go much deep into it. So here is OWASP. OWASP is the Open Web Application Security Project. Is a non-profit foundation to improve the security of the software. So all the enterprises generally follow certain standards in maintaining their applications, their networks and things like that. This is an organization which has given some standards and rules is what it is, guys, okay? And that is referred as OWASP. most of the time it is networking team who's taking care of these things, guys. We have to have an idea, so I will not spend too much time. So Azure Firewall, it is a managed network security service. Firewall means it is a network security to control the traffic in and out of a network. It is taking care. This is like a police who's standing in front of the mall and letting the people inside and outside. This is the security at the mall. This is for the complete mall. Okay, stateful. Once traffic is allowed, once traffic in is allowed, traffic out is automatically allowed. If you're allowed inside, if you come inside the mall, you can go. There's no problem there. Centralized configuration. With one Azure firewall, you can control the traffic from multiple networks. Okay, within a mall building, within a mall, there are multiple floors and things like that. Multiple networks are there. So you have one for mall security, that is Azure Firewall. If your enterprise has 10 networks and 100 VMs, you can control the traffic with one Azure Firewall, that is the mall security. It integrates with Azure Monitor, provides logging and analytics. So Azure Monitor is now coming into the picture, and it gives us information about the firewall, what is happening, who tried to get in, get out, and things like that, and so on. Then we have a web application firewall. A web application firewall is, this is a security inside your coffee, or let's say you're a bank. Inside a mall, there is a bank. Inside that bank, there's another security that is this is a firewall for your application. It is only a firewall for your application. Okay, so multiple applications can have their own security apart from the Azure network security. Everybody catching it, guys? Pick your please. Okay, then back here, use cases. Okay, Azure Firewall is an external firewall. This one is external for all the internal ones. So the bank has a separate security, the coffee shop has separate security, but all the stores have one security, which is an external security that is nothing but the Azure Firewall. It's outside your network, or it is at outside your network, but for the complete cloud, is what you can say. Network security group is like an internal firewall inside your virtual network right before your resources. Again, just a quick touch. I will not go too much into them. It's not necessary. Multiple inbound and outbound security rules can be created. Allow or block the traffic, restrict the traffic, attached with the subnets and network interfaces and things like that. So those are all can be configured, rules can be added. So here is a use case. Allow access to the web server only. So port 80 is if you want to access a server as a web server, port 443, port 80 and 443. So restrict database access only to web servers. So if you recall, the traditional architecture is, here is a database. And generally, what happens is there's a web server. Here's a web server. And then you have a UI layer. Let's say we'll give this as UI layer. So who can access the database? The UI or the others generally don't access the database. They only give access from a web server to that one to access the database. Okay, so that's where a network security group, we give the IP address and say, hey, only this IP address can access this one. That's a rule. Whether that's a VM or any other web server and things like that is what the network security group is, guys. Okay, so some security best practices, let's see what they are. Okay, a chain is only as strong as its weakest link. Secure at all levels. You have 10 people who are very strong, out of them one guy is very weak. As a group, your weakest link, how strong he is determines how strong the group is. Because if one guy loses them, that might result in losing all the group losing. So your weakest link is an indication of your strength. Physical security, control access to physical infrastructure. Again, because it is in the cloud, that is Microsoft is taking care of it. Nobody will access the physical servers. They are all somewhere in other parts and other continents of the world, safe and secure. Perimeter, again, this Azure firewall is forming the perimeter security. The security which is at the entrance, the outside security who is allowing the people in and out. Network security, again, that is also firewall. Firewall is kind of acting like network security. Then compute security, secure access to virtual machines, implement endpoint protection, ensure that OS and software patches are applied. So these are software patches is something which is coming from Microsoft. When they make some major changes, major updates to their operating system and things like that, those are the patches which are coming from there. And application, think of security from day one. In other words, if you have an application, who should be accessing the application, who should not be, what is their role, what is the permissions, that is again generally done at an application level. The password specific information is generally stored in Azure keyword. Data is encrypted and at rest in transit. So in other words, in transit means within the network, when the data is going from one server to another server, it is encrypted. That is also taken care of. So these are some of the best practices is what that refers to, guys. Okay. So now back to a little bit of different cloud models. So we've already looked at this one, public cloud, host everything in the cloud. You don't worry, no capital expenditure. Hardware resources, hardwares are owned by Microsoft. Hardware failures, security, everything is managed by Azure. Hardware owned by Azure and shared between multiple tenants. Multiple tenants means multiple customers. Customers who run the infrastructure. There can be many people. That is you, that is me, and other people working on the cloud. Public cloud means it's a floor where there are multiple stores. Starbucks coffee, McDonald's, and an Indian restaurant. They're all tenants, customers. Private is you host everything in your own data center. Needs capital expenditure. So this is like you're saying, hey, leave the entire floor to me. I don't want anybody else. Incur staffing. So obviously, we will need to put the more money. Delivers more security. Again, an example is financial organization. They don't mind paying more money, but their data needs to be very, very secure. Hybrid is a combination of both. We're using some from the public, some from the private. Use public cloud for some workloads and private. Connecting an on-premise app to an Azure Cosmos DB. On-premise app, it has maybe the application is on the on-premise or an application is in your company that is getting the data from the cloud, which is stored in Cosmos DB. So that's a hybrid. We're using both the on-premise and the data in the cloud. Provides you with flexibility and go on-premises or cloud-based based on specific requirements. So again, these are slightly, the decisions are made generally at an architecture level. Most of the times it is public cloud, and we may also come across the private cloud and the hybrid cloud often, guys. Okay, that's something to be kept in mind, but just keep those examples in mind. Hybrid cloud, going a little bit deep into the hybrid cloud. Okay, options VPN and Azure Express Route. VPN is virtual private network, encrypted connection from on-premises. On-premises is your company to the cloud over the internet. That is virtual private network. We need a VPN device or gateway on-premises. Within your premises, you have a device, VPN device. Need Azure VPN gateway in Azure Virtual Network. So again, that is something to be configured, generally taken care of by the administrators and things like that. For you, you need to remember, what is VPN doing? VPN is connecting your company to the cloud, for which we are maintaining, let's saying, get a device. It is referred as a VPN device. Another one is a virtual, say not this one, choose this one, gateway. Here is a gateway. So using these two, you're able to connect your company to the cloud. Express route is a private connectivity. So this is going on the internet. VPN is on the internet. So others may be traveling through that one, whereas the express route is private. Private means nobody else will be traveling. provides high bandwidth, very high security. Traffic does not go over the internet. Traffic is not encrypted by the connection, I say. So again, this is just only you both will be communicating, whereas here others will be also be communicating. Both of them are facilitating the communication between the company on premises versus the cloud. That is why it is called hybrid. In hybrid scenarios, we are using both of them. That's why we use these two things is what it is. Express route is another way of alternate for VPN, alternative for VPN. Everybody okay with this slide, guys? Quick yes, please. Okay, so here we are. Give me one moment and let's say come back here. So quick review. One moment, guys. Okay. Just seeing if I'm able to scale sets. Microservices. Storage. We're not able to create the storage, but let's see. Azure file storage. So we'll need to go back here. Part 2. Version 1. Part 2. Version 2. Version 1. Let's go here. Pardon me. Contain instances. Okay, need one of you guys to, let's say, Satish, are you able to come back online? Can you share your screen, please? Satish, are you there? Okay, Satish is not there. Let's see, how about Lavanya, are you there? Can you come online and share your screen? We'll try to perform some labs here.
Yes, Naveen.
Great. Let me make you the co-host. You're the co-host. Okay, Satish, go to message. And Lavanya, access the lab once you are ready. Share your screen and access lab when you're ready.
Yes, Naveen. Actually, I opened it in morning. I think it's not working. I need to start from beginning. Give me 1 minute, Naveen.
Are you able to share your screen, Lavanya?
It's loading and I just clicked on start and it's in
Okay.
progress.
Okay, let me know when you're ready. Try
Okay.
to create.
Yes, Naveen?
Okay. Okay, Lavanya. We'll try to create an app service. Try creating an app service. Just search for app service. Go ahead and create one. Create new. You can create a new group, or you can select an existing one if you have one. You don't. Okay. LD1. Don't say LD1. It will be confusing. Say RG1 so that you know it's a group. Web app name, you can give, just say first web app, something like that. Okay. Then I think for now we can choose a Docker container. Docker container is all.
Saying that the first web app is not available.
First web app, the Lavanya, first web app Lavanya. Give your name there. And we'll choose Docker container Linux, and then okay, you can 100 total. You can change the premium. Scroll down, change the premium to. Click on change size. We'll choose dev test, and we'll choose something small here. Let's see what I have chosen as 100 total ECU 1.7. Basic B1 is what I have chosen. Scroll down, please. See if you can find. Oh no, you select the dev test. Your production is selected right now. 1 GB. Select the green one. Apply. Next, go to the Docker. And we can say single container and engines. Okay, leave the defaults. Go to the next. And I think you can just directly say review and create. Click on the right arrow. Or is this a thing disallowed by policy? Okay. I see. I think this is the same error we faced yesterday. We're back. We're not able to create this. Okay. In that case, what we can do is container instance Kubernetes, we don't need to. I think Azure function also we had a problem yesterday. Go ahead and just close this one. Now let's try an Azure function. Let's see if you have any luck here. Just type in function, not Azure. Function app. Yeah. Create new. Yeah, create function. I will give select your resource group. Give some name. Say my function Lavanya. No. Resource group, you give RG1, select RG1. Here you give my function, Lavanya. And keep the code as code and the runtime stacks. Let's select Node.js for now. Node.js, 14 LTS and Central US. I think will automatically then go to next. I think you can click on, let's say. So yeah, you can directly go ahead and do a review and create. Create. Give it a moment. Oh boy. Go into the raw error. Raw error, please. Click on raw error. Yeah.
Yes, Navin, already in the page.
Okay. Okay, so we're not able to do that. Let's try another one. Sure, we'll not be able to create logic counts. Source group. Okay, can you go into the search window, close this one, and just type in resource group. Select resource groups. Select RG1. Oops, not create. Yeah. Okay, so right now it doesn't look like we have any resources. Huh? Do we scroll down? Nothing is there. Okay, that's because sorry about that. I think until we get this resolved, we'll not be seeing any resources here. And let's see what else we have. So I come here, see what this one is. Machine. So it's the storage. Storage account, and I guess that won't work. Maybe we can try a database. One moment. Okay, close back to the search window and just type in MySQL. We should see Azure database for MySQL servers. Okay, select that and create an Azure database for MySQL. And then create a single server. And let's see, select an existing resource group, RG1, and enter server name. Yeah, just give your name, something. Say Lavanya DB or something like that. Lavanya server DB server 1. Okay. And data source, yeah, that's okay. As long as it something as works. And location, currently the service, oh, service is not available in this location. Just choose a different, these two. Okay, doesn't complain. Next, let's see. I think we can leave these things. Give a admin username and a password. Something, say Lavanya admin or admin Lavanya. Something like admin $123. Okay. Cannot contain all or part of the login name, I say. Just say admin $123. And double encryption, go to the next. Tags we don't need, go to the next. Let's see, scroll down. General purpose, compute plus storage, okay. Okay, click on create. Let's see if we have any luck with this. So it's not even allowing us to create. Okay. Okay, so I guess we'll need to really wait for them to come back. Don't think we'll be able to resolve this one. So in that case, let's see where we are. 342. Okay, guys, take a short 10-minute break. We'll regroup and you can stop the sharing, Lavanya. Let's take a 10-minute break, guys. Okay, guys, are you back? Can you give me a quick yes, please? Okay, so let's continue the journey, guys. We'll try to get back and review a few concepts for another time. Back to the Azure DevOps and services. So if you recall, most of the time DevOps is coming into the picture where there's a developer team and a build team. The developers team will develop their code, will test their code and give it to the deployment team. When the deployment team tries to deploy the code, it may not work as expected, or it may work with many problems. In other words, the problem is it works in one environment, but it does not work in other environment. That's where the culture of the DevOps has come in. We spent some time earlier on that one, but we'll revisit that later. But as part of it, using GitHub. GitHub is a platform that is used for hosting source code repositories. So in other words, it's a platform which Microsoft has acquired, and it is our web-based version of source code repository. Anytime we make a change, we write some code, we make a change, every version that we save can be checked in. And every version that we check in is generally saved on the web. In other words, multiple versions of the code files are getting checked, guys, checked in, not saved. These repositories can be versioned with the use of Git as the underlying version control software. So in short, it is a web-based version control software. It is the most popular Git hosting platform. Again, it's very popular. It is part of Microsoft. Microsoft acquired it. We can pick up code in GitHub and use it in Azure DevOps. Okay, we'll try to see that if time permits. Azure Dev Test Labs. This is a service that allows developers or teams to get up and running with resources such as Azure virtual machines without waiting for approval. So with Dev Test Labs, we can create labs based on a pre-configured Azure Resource Manager template. So many times what happens, guys, the testing team, the QA team may not be very technical. So what an architect may do is he will create a template in the form of an Azure Resource Manager template, and he will hand it over to the testing of the QA team. They can run it. So whatever the resources, the configuration, the specs are mentioned in the Azure Resource Manager template, they will, the template can be uploaded and the entire architecture is created for them. That's what that is, guys. Okay, so just at a slightly high level. We can also set policies. We can also set auto shutdown. So all these things are actually, the architect really builds up all these configuration points and hands over the template. We just upload the template and run it, and all the resources, VMs, that could be 1 VM, 10 or 100 VMs, all those things will be created for the testing team, guys. Okay, just a little bit about Dev Test Labs, but moving on a little bit, serverless services. The benefits of serverless services, we don't need to maintain the infrastructure. We also don't need to maintain the underlying software hosted on the computer, on the compute infrastructure. We don't manage the software. We write the function and leave it there. Within the function, as part of the function, we try to write all the appropriate logic. The application logic, the business logic is what we will be writing, we will be responsible for. Normally for serverless apps, you pay for what you use. In other words, you may have used it only for a few seconds to a few minutes, you just pay what you use. This is a large cost benefit for companies. Okay, so in other words, a lot of, as I said, it saves a lot of expenses. Capital expenditure is reduced, even operational expense is also reduced. That is what, if you recall, it's like, imagine, I think we were talking about Divya. Divya has a Starbucks coffee, she's running the whole day. But here comes Ganesh, he is going to run only a few hours. So his monthly expenses are also going to be reduced. That is what is special about serverless services. Azure Functions, this is a serverless compute service. We can deploy the function, we only pay. As long as the function runs, it might be only 1 second, 1 minute or 1 hour. Only that is the amount we are paying. Serverless Kubernetes is used for deploying your container-based applications. So Kubernetes means a group of containers. A container can individually contain an application or web application or whatever it is. So again, when we create a group of containers also, that is acting serverless, which means we are saving a lot of cost. Back to Azure Logic Apps. This is used to design workflows in Desire in Azure. So in other words, a workflow is a group of steps, a group of tasks. Business users can create workflows and integrations. Okay, so a business user, without really knowing any code and things like that, the objective is they should be able to create their logic apps. Workflows can connect to a variety of Azure services and third-party services as well. That's where a lot of automation and all those things come into the picture, but that's a slightly at a high level, guys. Okay, Azure Event Grid. This is the event-based service in Azure. Events are getting fired when you do certain things. Here we can work with the events generated from Azure, and we'll see what it is. Azure API management can be used to manage various backend APIs in the form of classes, RESTful services, and things like that is what it is. That also we'll discuss, guys. Okay. Azure SQL databases. Again, this is a serverless version of Azure SQL database. Here again, you pay only what you used. You can pause and resume. That's a very big cost advantage. Even the Cosmos DB is also serverless. Okay, so back to functions, going a little bit deep. Serverless compute service is available from Azure. We can code in C#, F#, Node, Java, PHP, Python, whatever you know. Consumption, pay for what you use. We can integrate with other Azure services. So the virtual network, it's a group of subnetworks. And what do? That is Azure function. Okay, so the Azure function runs. It is nothing but a small piece of code that could be very sophisticated, or there could be very, very small piece of code is what it is. It has input and output. Just like a function takes input and gives out the output, the Azure function may give the output, or sometimes it may not give the output. It will just do some saving to the database and things like that. So Azure Blob, whenever an object is added to Blob, invoke the function. We may want to write something like a code where we are saying when a particular blob means it could be a file or maybe an image, a video or an audio is added. What we want to do is take that as input, and then what you do, you write it to a function. The function can add the data to the Azure table, saying that, hey, a new video file has been posted here, or a new video file has been added here. What is that? That's a simple example of an Azure function. Costing consumption plan on or app service plan. So again, pay as you go. You get only charged for your time, and maximum allowable execution time is 5 minutes. Okay, there you go. So Azure functions, they're limiting it only to run 5 minutes, not more than that. App service plan. Have instances allocated, having the function running for longer, using more memory, just in case we have more, we need more time and things like that. Then we can also run it using a app service is what it means, guys. Okay. So coming back to the Azure Event Grid, we can take advantage of the Event Grid service to listen to events emitted by Azure services. So in other words, many times in Azure, as we are creating, deleting services and things like that, what we can do is many events are getting generated by Azure. We can listen to the events, which means when a certain event happens, when somebody creates a file, when somebody creates a record or anything, we can take that event, we can read that event, and we can do something else. We can subscribe to the events. So you're telling, hey, when somebody creates it, I want to be notified. That is called subscription. We can then define. So in other words, when you subscribe, you get a message. That could be your object. We can define an event handler that can be used to process the event. That is nothing but the function. You handle when certain event happens, that becomes your input. You write a function that becomes Azure function, and then you do whatever you want. You can also define your own custom events. The service is highly available service because it is spread across multiple fault domains and available zones in region. So in other words, again, the availability is high, as simple as that. Okay, so here it is. Blob storage, event hubs, and resource groups. When somebody adds a object to the blob, or when some event happens, or when somebody is adding a resource, deleting a resource, what can you do? You can say, notify me. That is what is Event Grid. It will give us a way to know that something has happened. And then what do? You trigger an Azure function, you trigger a Azure Logic app, or maybe a web hook, which is like doing some web related thing. Then again, logic apps, they help you automate, orchestrate tasks. Logic apps is a group of tasks. It is automating a group of tasks. That is another group of tasks is nothing but a workflow. Various templates are available. So again, a lot of templates are available, and they're fully managed. We can build workflows. We don't need to worry about the infrastructure again. The workflows can integrate with various Azure services and third-party services as well. We can build workflows by a visual designer also. Then again, that is mostly for business users who are non-technical and things like that. We can also give a visual designer. So here is a part of it. And what do we have? It has a connector, and the connector can connect to a blob and a function or a service bus. So here are the parts, which is nothing but the triggers. Some of the connectors like Azure Blob Storage have the facility to trigger the Azure Logic App. Trigger means when something happens, that could be creating a file, a video or audio. What is that? You trigger something. You want something to happen. That's what is called trigger. You may trigger a Logic App. So here is a blob storage. And whenever an object is added, you're triggering the Logic App is what you're trying to do. Okay, action. What to do when an event is triggered. So you first trigger and then you decide what to do. Do you want to send an email? Do you want to call another function? That is what is action. So triggers and actions are called the parts of the Logic Apps, guys. Okay, once our access is back up and things like that, we'll try to take a look at an example of that in the coming up days, guys. Maybe we'll give it a day or two. And back to Azure Cosmos DB, it is multi-model, low latency, which means very highly performant, instant replication. It is taking care of the replication. It is automatically scaling. It is fully managed. It is also serverless. Okay. So here is multi-model. We have a Cosmos DB account. It can work with SQL table. It can work with a NoSQL. It can also work with the MongoDB, the graph-like table, multi-model, and with different models, key value. It can work with graph-like database and things like that. Again, 5 nines availability. It can scale up to thousands and hundreds or millions of requests per second. Especially when you need millions of requests per second, the traditional databases fail. That's why the NoSQL databases come to your rescue. So Cosmos DB guarantee less than 10 milliseconds for reads and index writes at 99 percentile. So again, that is a little too deep. I don't think we need to go that far. But remember, if you want millions of requests per second, then Cosmos DB is a good candidate. SQL, MongoDB, and all these things are used. So here is SQL API. Again, internally, it has something called a partition key. Partition key is like the primary key, the main column inside a database is what it is. Throughput. This ensures Cosmos DB allocates the right resources. So we'll try to understand throughput. Let's go over this one. The throughput is a combined measure of CPU, memory, and IOPS. CPU, memory is RAM, IOPS is how many reads and writes it can perform. The measure of these three things is referred as a throughput. It helps have an even measure, no matter which API you choose. In other words, it is used for measuring, guys. More of a database administrator's terminology. The throughput is measured in request units. The cost to read 1 KB item is 1 request unit is what it is. And billing is done on an hourly basis. So just remember, over here, out of all these points, throughput means it is a combination of CPU, memory, and IOPS is something. Maybe I will ask you to remember. The rest of the things are more of an academic importance, guys. Okay. Then back to database. Azure SQL database, we just discussed about it. It is platform as a service. The infrastructure is managed by the Azure. Flexible deployment and pricing options. Access to the latest features of the Microsoft SQL Server are given as we use that one, guys. Okay. So between PaaS and IaaS, in PaaS we have 4 nines availability and built-in backups and recovery are automatically done. Some minimal set of features may not be available. In platform as service, it reduces infrastructure maintenance costs. If we go the route of infrastructure as service, we have full control of the software, but we need to install, we need to configure, and tomorrow if we need to migrate, we have to do it. We need to patch the system. We need to manage the availability. So in other words, platform as service will be much more better choice when we choose the Azure SQL database, guys. Okay, everybody with me, guys? Quick yes, please. Gentlemen, ladies, are you with me? Slightly heavy theoretically, academically, guys. The nature of the AZ900 is slightly theoretical, so just bear with me. So create a SQL database with underlying server. The server is managed by the Azure. So in other words, it is Azure, it is managed service, which means again managed by Azure. Complete PS option. That is a managed instance. Managed instance is good for companies who just need to lift and shift their existing premises database. So somebody has a database in their premises or in their company, and what they want to do is they say lift and shift. You want exact. Ideally, you'll make a backup of it. The backup is a file, and then you will transfer it into your cloud, and then you will do restore. That is what is called lift and shift. Okay, so a little bit of terminology. And database transaction unit bundles measures of compute, storage, and IO. That is nothing but the throughput. It is good for companies who just want a simple option for managing their underlying resources. So again, SQL database, Azure SQL as a platform is a better one. Here, customers choose the amount of compute and storage, and this gives more flexibility and control to the underlying resources. The vCore model is also ideal if you already have existing licenses, guys. Okay, so again, just a little bit of theory there. We can use the traditional tools. We have something called SQL Server Management Studio if you want to connect to a SQL database. Visual Studio IDE, .NET programs, we can also come connected from Cloud Shell, which we are unable to do, and that is what we are working on. Then we have the Azure database for MySQL, same as the SQL Server, but subtle differences. This is a platform as a service that is available for MySQL. So instead of SQL Server database, we are using MySQL. High availability is built in. You can also get automated backups, point in, time restore. So again, that is managed. Underlying service is responsible for maintaining the underlying hardware and keeping up the database. So again, managed, taken care of by the Azure. Here, the company does not have to pay the overhead of maintaining the infrastructure. So one more time, that is also taken care of by the Azure folks, guys. Okay. Postgres also, most of the things are same. Company and the infrastructure is taken care. Database is taken care. Backups, restoring is taken care. Availability is taken care, guys. Okay. Then we have the managed instance, Azure SQL managed instance. This is again a cloud-based service for hosting an SQL database. Okay. Here, the main benefit is that underlying database engine has near 100% compatibility with the latest SQL Server Enterprise Edition database engine. So if a company is heavily into the SQL Server database world and things like that, they will generally go into managed instance, and they will have all the latest versions of the SQL Server is what it is, guys. Okay. This makes it easier for companies to lift and shift. It also provides native virtual network implementation. We get the features of high availability and backup. So in other words, everything is same, except that if you take the managed instance, you will get the latest SQL Server Enterprise Edition. And there are a few companies where we will need the, which are heavily working on SQL Server and things like that. For them, the SQL Server managed instance is probably better, but most of the time, they go by Azure SQL database directly, guys. Okay. They don't go by the managed instance. Okay, so a little bit more theory, guys, bear with me. Enterprise data warehouse. So Azure data warehouse, it is used for storing petabytes of data. We just discussed about it. It is a perfect data store when you want end-to-end big data solutions. So in the world of big data analytics, again, what is it? Well, that is nothing but Synapse Analytics. Data is stored in relational tables using columnar storage. So it is stored in the form of tables. It is like structured data getting saved, but behind the scenes, it is a column-oriented database. Storing data in such way reduces the cost and improves the performance. we can perform query analysis over large data sets. So in other words, big data. Remember that the data warehouse is not used for transactional data. Transactional data is traditional database. Relational database or data warehouse is used for analytics, not for transactional, guys, okay? So here is a little bit of architecture. The control node is like a master node. It has a lot of compute nodes, just like our slaves or workers. And what happens? Applications connect and issue TSQL commands. So behind the scenes, it is nothing but the SQL programming language is at work. The code is moving to the different nodes, the workers, and that's why they're called as the compute nodes, like the workers or the slaves in the Hadoop. And the parallel processing is happening. So the parallelism is inbuilt into the data warehouse, which is nothing but the Synapse analytics service. This is an analytics service that helps enterprise data warehouse, big data analytics solutions. There are currently 4 components: Synapse SQL, Spark, Synapse Pipeline, Studio. These are some of the things next week we will see and discuss some of these things, guys, okay? So SQL pool, this represents a collection of analytics resources that are provisioned when using Synapse SQL. So it is nothing but a group of VMs and things like that. They are maintained as a pool to maintain the high availability and things like that. And we can import big data into the pool with the use of TSQL queries. TSQL queries is almost nothing but SQL queries only, guys, okay? They call that as TSQL. Some minor and certain differences are there, but most of the time TSQL language is nothing but the SQL language of the Microsoft Word. Your business can then gather insights. In other words, using SQL queries, we will write our queries, we will try to understand some insights, and that is being done on the big data in a data warehouse. So here is generally the process of the Azure Synapse Analytics service. Let's see what that means. Okay. The first step is we get the data from mobile, we get the data from social media, Twitters and things like that. We ingest the data. Ingesting the data means saving the data into the world of big data. You're getting the data, you're ingesting the data. Then the data is stored. When you store the data, what do? You prepare it and train it. In other words, you analyze it. In the world of Hadoop and Spark, big data analytics, that's where it comes into the picture. You analyze the data, and then you can also build the models. You can also use machine learning. And you build the machine learning, and then the machine learning models help you in making predictions. Based on the predictions, the companies make decisions. That is generally referred as a big data pipeline. These are the high-level steps that generally happen in a data analytics or a big data analytics world. Okay, so Synapse Analytics, what is happening? Control node is like the master node. These are the users who are using it. Behind the scenes, it's performing parallel processing, and the workers are like the compute nodes. All of them are enterprise class servers here. Okay, so Synapse SQL uses a node-based architecture. Node is nothing but a computer or a server. Here, applications or users connect to using, again, we have seen this one. The control uses MPP, and the compute nodes perform the work. They are the workers. Workers do the work. A data warehousing unit is a bundle of 3 resources: CPU, memory, and IO. Here and there, maybe if you're sitting with an architectural team and things like that, your colleagues and things like that, they'll be throwing some terms at you, throughput and things like that. What is that? It's the combination of CPU, memory, and IO. A measure of that is referred as a throughput. The more the throughput, generally more the performance. When you create an SQL pool, you have to mention the number of data warehousing units you require for the pool. Data warehousing is generally not, creating the pools is generally done at an architectural level, guys, okay? Because it involves a lot of money and things like that. These are expensive servers. But this is just to give you an idea one more time, a bunch of academic stuff here. If you want higher performance for your pool, you can increase the number of units. Okay, that's more of an academic thing. Now here comes a slightly different one, Azure CDN. It effectively delivers effective delivery of web content to users. Okay, we'll try to understand what that means. Users around the world get a seamless experience. Popular content can be cached. What that means is, here is a web application. It is deployed in Central region. Earlier in the morning, we discussed about a web application getting deployed in the London region. But here it is deployed in a US Central region. The users in US Central Region will be able to access it fast. But if the users are in other parts of the world, because for example, in India, Africa, Australia, that is too far away from US Central Region, what will happen? They may see a latency because the distance is too far away. So what do we want to do? We don't want our users to expect delays. So that's where CDN, Content Delivery Network, comes into picture. What it does is it maintains a group of servers called edge servers. What do these edge servers do? They are located in different parts of the world. When we have a web application, the web application is not only available in US Central Location, but wherever these edge servers are there, it is also deployed. What is that? That is Content Delivery Network. These are the edge servers at different parts of the world, in different parts of the world. So now, if you're in India, the closest edge server, your requests are all directed to the closest edge server. That's called as an edge server, not a web server, an edge server. And your closest edge server processes your requests. So as a result of that, what is happening is you get a faster performance. What are we doing? We are distributing the content across various regions. Just like Hadoop is distributing the blocks across various servers in its cluster, here the content is nothing but your web application or your code. It is getting distributed across multiple parts of the world, is what you can think of, guys, okay? If a request is made from a user to the Azure CDN endpoint, the request is sent to the closest point of the presence. That would be the closest edge server. If the edge server in the point of presence does not have the resource, then the edge server will contact the origin server. So the very first time, if an edge server does not have that content, then what will happen is it will go to the original server and copy it and paste it itself, code and everything, the setup. And that is automatically done. The resource is cached on the edge server, means it is in memory so that it is fast and quick and available. The resource will be cached in the point of presence based on the time to live. Okay, so again, there is something called time to live, how long you want it to be in memory versus and things like that. That is configurable, that changes from application to application, guys, okay? So we create a CDN profile. We can attach, this is also an expensive operation. So generally, it's probably better we don't. I will not create it, guys. That's what I'm trying to convey, but just going over the theory. Then we have Azure tools, IoT Hub, Machine Learning Service, Machine Learning Studio. This is where all the money is today. So IoT Hub. So all these things that we have learned so far, everything will come here, guys. Okay, all the data is being taken in. This is where the magic is being done in real world. And that's what everybody is trying to understand, the data. So IoT Hub is a message hub. All the messages are stored here. That's why it's called a hub. It is used for bidirectional communication between IoT application and IoT devices. What are IoT devices? Your sensors. Sensors, what are they doing? They may capture your video, audio, maybe the temperature, maybe the humidity, and all these things, and they will transmit the data to a central location that is nothing but the hub. And then our IoT application takes this data, it will analyze the data, it will try to give us insights, some knowledge. That is generally what is done. It is fully managed. Again, hub is completely managed by the Azure, and we can have the different kinds of authentication techniques here. Control over the device access is also given to us, guys. Okay, just a little bit about hub. For you, IoT Hub is all the messages from the different sensors are stored at one place, that is referred as the hub. Now this is a big one. Machine learning service. It is service used to train, deploy, automate, and manage machine learning models. For this course, generally it is too much. In other words, it is out of scope. Understanding a model, understanding data, training a model, these are all slightly advanced tasks and concepts, guys. It takes a lot of time for us to digest all these things. So, but a quick idea here. We can build models. If you have data, we can build models. Using the models, what can we do? We can predict. Imagine there's a cricket match tomorrow. We can predict if India is going to win or if India is going to lose. What is the score each player is going to score? A ball by ball, we can make a prediction who's going to get out, what is the next ball one is going to score. All these things can be done based on data. From the data, they build models. What is that? That is machine learning. So we develop, again, Python is the godfather. In other words, he's the big brother when it comes to machine learning and deep learning. Most of the world goes to Python when it comes to the data analytics guys. Okay, so create compute target. So in other words, we write Python scripts. That's why Python, all the concepts that we have learned, they will all end up in writing these scripts. And the good thing is you don't have to become a big Python expert to create machine learning models. With the basics that we have learned so far, we'll be able to create machine learning models. That is why everybody is going after Python guys, okay? So machine learning service, generally what we do is we build a model, you test it and see if it works well or not. If it works well, they release it to the rest of the world and say, hey, I have built a model. The model is coming from data. And they say you can use it. You can use it for making predictions, maybe the temperature, maybe the stock prices, or anything and everything. So Machine Learning Studio is a simple drag and drop tool, a very advanced tool. It just works on the principles of dragging and dropping, and a very, very fascinating tool, guys, okay? And we can use this tool to do the predictive analytics. That's a buzzword today. All the AI and all that stuff converge here. They're all doing predictive analytics. You can easily drag and drop. So all the services here, they are provided as modules. We can just drag and drop them and build the models. Data analytics is generally performed here. They are referred as experiments. After running and training the experiments, if we are happy, we can release it to the world, and that is referred as a predictive experiment. It is released in the form of web service and things like that, guys, okay? So let me see where I am, okay? Still have more time, let me complete a little bit more here, guys. Azure SQL, again, we have discussed about the data warehouse, data lake analytics, okay. HD Insight, this is nothing but the Hadoop in Azure is referred, it's a distribution of Hadoop. It's open source, and you can run Hive, Pig, Apache, Spark. Spark is the latest and the greatest, built with full redundancy and high availability. Again, we discussed in detail about Hadoop, the way it maintains replicas, how it distributes. If one server goes down, we have the data available in another one. The service automatically deploys. So we can create a group of virtual machines using Azure HD Insight. Data Lake Analytics also is a solution for big data. It allows you to run terabytes, queries on terabytes and petabytes of data, just like our Hive and things like that. That's what this is. It uses a SQL language. We can also use Visual Studio to work with data analytics, guys, okay? Then a few more things, the PowerShell, the command line shell, that's what we were trying to use it, but we are having a slightly tough luck there. And it looks like our folks are still working on that. So Portal, again, we can use Portal. On the Portal, we are trying to use Cloud Shell. We can also use, you can run PowerShell on Windows, Mac, and Linux also. PowerShell was generally a Windows thing, but today we can also, it has also become a platform independent tool. Azure command line interface. This is a specific command line interface for Azure. You need to install the required tools. So again, this is just like our the command line interface, command prompt. Only for Azure is what it is, guys, okay? Then back to container instances. This is a service that allows you to easily deploy containers in Azure. So it is, we have created one container yesterday. I think one of them was having problem, but another one. So container is where you can deploy multiple applications and things like that. Rather than creating a virtual machine, today we create a container, and in that container we try to host our applications because they are more lightweight. You don't need to manage the underlying virtual machines. The container groups deployed via the Azure container instance gets an IP address and a fully qualified domain name, FQDN. So you can deploy both Windows and Linux containers. Let's see how much we have here. Okay, we're almost at the end, guys, okay, for today. Understanding the Azure Kubernetes service. Kubernetes, again, it is a tool for creating a group of containers. This is the ideal tool the team uses to deploy microservices-based applications. And the Kubernetes service provides both stateless and stateful applications. So again, that is slightly deep at this stage. Stateless is where you have some data and stateless. So stateful is where your data depends on the data, state of the objects and things like that, guys. Okay, let me see if I can simplify that. Stateless is imagine if you have a list of countries or a list of days in a week, a list of months in a week. They don't change. So what can you do? That is stateless. Okay, you can always maintain that data just as it is, they don't change. Stateful is where the data might change. So again, for you, you don't have to worry about stateless or stateful. But one thing I'll force you to remember is Kubernetes or K8 service is helping us create a group of container instances, as simple as that. That's what you need to keep in mind. And again, available on Azure. This helps reduce the complexity that is involved in deployment and working with core management tasks. So in other words, it's if we have to create all the container instances, it's a manual process. It is a time-consuming process. Many times we want to automate this one. That's where the K8 comes to our rescue. K8 is nothing but Kubernetes. It has internally pods and deployment is the language. This is used to run an instance of the application. The pod represents a single instance of the application. Normally, each pod is mapped to a single container. So again, pods, all these things are nothing but like our workers in our Hadoop architecture. A deployment is used to represent the deployment of one or more identical pods. If the Kubernetes scheduler finds out the pods or nodes encounters any issues, additional pods are created on healthy nodes. So these pods are nothing but small process running on nodes. Nodes are nothing but workers. And if there is any problem with this process, then more healthy nodes are created is what it is, guys. Okay, so that's a little bit of theory, guys. Just introducing you to some of them. You don't need to know all the details, but we'll go over some of these concepts tomorrow and continue our journey from here, guys. Okay, everybody okay with that? Quick yes, please. Okay, so any questions before we wrap up today, guys? I will try to pass on this one today to you guys. Yeah, and I'll put it on the drive. You try to download it and pass along within your team, guys, for those of you who may not have access to it. And the quiz and things like that also I will try to incorporate. I will try to pass it here, put it here, and share it with you guys, okay? Go over those things also.
Naveen, please share this in the drive which is Savitri shared, because we are unable to access your drive in company laptop.
Oh, okay. Yeah, I think I do have that one. I will share it. Can you share that link one more time?
Okay, Naveen.
Just here, and I will just say pause this screen and stop my thing here. Let me come back here. Maybe I'll share it while you guys are here so that it becomes easy for you. And there is the functions, serverless functions. This is the storage. Base fundamentals. Okay, come here. Let's say it's right here. And let's say come here. Click on this one. Oh. Say copy this. Back here. One moment, guys, while I'm uploading it. Click on here. Close this one and we'll put it in PPTs. Say come back here. one. Go here. Managing resources, version 4. Right. Multiple regions. Top storage. Right here. Okay, so let's say from here till here, this one. Organizing and managing Azure. This here. Right. Or 2 version 1. Right. Put this here. And power advantages of regions, best approach, activity logs. Vertical scaling. One moment, guys. I'm just incorporating all these things into one slide before I upload. Okay, so let me save this one. Save. Okay. Fine. So let's say version 3, part 1. This is part 1. And so those things, delete them. There's in here. Okay. I will save this as 2 parts. Save this as part 2. And we can add more to the part 2 later. So I'll come back here. Okay, file, save. Save this and save. Next one is file, part 1. Save as. Save it. For part 2, we will probably add a few more in the coming up days, guys. And it's part 1. Part 2 is okay. Uploading now, guys. You can check it. So back to TM. Date modified. Oops. This one. Okay. So let me come back here. Take Mahindra. PPT. I think version 2 is there. Is it 900? So let me share my screen. Let's say new file upload. Part 1, part 2, let's say open. Part 2 is the one that we covered today, guys. Part 1 is up till yesterday. And I will rename this one as the old one. So I will call this as V2 underscore old. Okay. So here is part 1. This is till yesterday. This is what we covered. All our questions and things like that will be here in this one. So have a look at this. And earlier, I think we were reviewing this one. These are the other questions and answers I want you to go ahead and review and be prepared in the coming up days for the assessments and things like that, guys. Okay, Lavanya.
Thank you, Navin.
Great, thanks. Let's see where we are, guys. Okay, and what else is needed? Let me pause the share here for a moment. See how many are here. Okay, a bunch of them were there in the QS. So prepare this queue as well, guys. That should be helpful for you to get through the AZ900 and trying to prepare one for DP900 also, guys. Okay, if you don't have any questions, you can sign off, guys. I'll be here for a few minutes and I will sign off in a bit here. Just check something and sign off, but feel free to sign off if you are done, guys. Okay. Okay, signing off for today, guys. Thank you. Yes, take care and stay safe and keep learning. Thank you and bye for now, guys. Thank you again.